Today we are going to cover the topic chemical bonding and molecular structure. Now all of you have done probably atomic structure by now and you know what is an atom, right? So atom is the basic unit of matter, right? Which can't be divided into anything else and it's indistinguishable. You all know all the features. Now when we talk about bonding, what we are saying is that these atoms, none of the elements in nature has any, none of the elements in nature have such a characteristic that the atoms can alone exist alone, right? So except for the noble gases, so noble gases can exist alone singly, but otherwise most of the elements will have atoms which will combine with other elements and give you a molecule. So molecule is what? A group of atoms, right? So molecules are a group of atoms. And how did these molecules get formed? The atoms had some kind of forces which joined them together to give a molecule. So when we talk about molecule, we say there are a group of atoms and atoms will combine to give you a molecule. Now, that means the first part is a chemical bond. That's the most important thing. So you will, in the nature, there are so many, everything in nature is made up of chemicals. All the chemicals are basically made up of molecules. So the molecules will have what kind of forces? Some sort of forces which will hold them together. The attractive forces are of various kinds, you know. The attractive forces are of various kinds. One, they could be ionic in nature, they could be covalent in nature, or they could be coordinate bonding in nature. Now, when we talk about molecules, just see the example of molecules. Let's say we talk about O2 molecule. We talk of hydrogen molecule. We talk of water, methane. These are all molecules. In the case of oxygen molecule, you only have one kind of atoms, oxygen and oxygen. In the case of hydrogen, you have only hydrogen and hydrogen. Water, hydrogen and oxygen. Methane, carbon and hydrogen. So all these molecules are formed from the atoms by some sort of forces. Similarly, you have sodium chloride, calcium chloride. Again, these are also molecules. Although they are different in nature from these, but they are all molecules. Some sort of forces are holding them together. Similarly, let's say ammonium ion. Again, some sort of forces are holding this ion together. So these forces, these ions, these molecules are important for nature. How did they get formed? Why did they get formed? And that is what we are going to study today. So fun thing is, why did they get formed? Because there was a need for that. In the nature, the normal rule is everything goes from instability to stability. You've already done that. हम अगर किसी चीज को ऊपर रख देते हैं higher energy level पे, तो it will always fall to lower energy. So whether we talk about potential energy, whether we talk about any kind of energy, the energy will tend to reduce, right? Anything will want to go from instability to stability. So bonding is another way of nature to reduce, to achieve the stability. तो stability कैसे आएगी? Atoms जिनकी higher energy है वो combine करेंगे by some sort of forces and will form a molecule. And in this process, the energy will decrease. So in fact, when I asked this question, this came in CET. So during the formation of a chemical bond, what happens? What is happening? The energy is decreasing. In fact, one of the diagrams that we'll study, potential energy diagram later in the class, probably tomorrow, is how did the energy get decreased during the valence bond theory. Okay, so bonding is taking place to form the molecules, right? So who were the first people? There were many theories which were given. You know what are theories? Theories are, there are some sort of concepts, some sort of ideas needed to explain certain things. Nature is doing everything on its own. It doesn't need us to explain it. Nature doesn't need us. It only, we need to explain the nature because we can use some of those characteristics on our own, right? So there were many theories given by many people. In 1912, Bohr gave his atomic structure, right? There was no quantum theory at that time. You've already done some sort of atomic structure, so you know that Bohr gave his model first of atom. After that time, it was given in 1912. 1916, Causal and Lewis independently, using certain ideas, gave a theory to explain the concept of bonding. Their theory was called as electronic theory of chemical bonding. Right. So they were the first to give you some sort of explanation. How did the bonding take place? How did the molecules get formed? Now, please understand all the theories, whether you talk about any kind of theory, there'll be a previous generation which will give its own ideas to explain something. Some of the ideas will be valid and some of the ideas will be rejected as the time goes on. Again, later on, some other people will come who will be able to explain some part of something, but will not be able to explain the other parts. So with time, like for example, right now, some things we consider true, but maybe 15 years, 20 years from now, when you're all grown up and very, you will come up with any theory to explain something which is different from what we are understanding right now. So theories will always be there to explain certain things. All the theories will have certain positive points and certain negative points. So causal and Lewis theory was at that time a very revolutionary theory in the sense that it explained many things. It explained the structure, bonding, but was not able to explain certain parts, right? So first thing is, how did Causal and Lewis decide on the theory? Now, Causal, he's talked about certain things. He said that in the periodic table, you've seen the periodic table. I don't know whether, oh yeah. Uh, in the periodic table, this is the periodic table. Can you see? You have alkali metals and you have noble gases, and then you have halogens. So alkali metal, between alkali metals, if you just roll it around, between alkali metals and halogens, which are both reactive in their own way, one is highly electronegative, the other is highly electropositive, there is noble gas, right? So there is something which is different. So Causal said that in the periodic table, the highly electronegative halogens and the highly electropositive are separated. So there must be a reason for them separation. Also, he said the noble gases are not reacting at all. So there is something special about them. They don't want to react. They have certain sort of stability. Nothing wants to go from stability to instability. Everything wants to go from instability to stability. So noble gases are not reacting. So there is something special about them. So why are the others reacting? Because the others want to achieve that kind of stability. So the stability can be achieved by what? Either you lose an electron, or you gain an electron, or you share an electron, and you get what? A stable noble gas configuration. So what it means is that in the periodic table, you have noble gases which are not reacting at all. They are stable in nature. They don't want to go anywhere. They don't want to do anything except for some compounds of xenon and krypton. No molecules have been detected. You don't know there is helium. There is no helium-2. Why is there no helium-2? Because it doesn't want to achieve that. It's already very good and happy in the native states. So the others are doing it because they want to go from instability to stability. So they will have to react. So Causal gave that approach. Now Lewis, he was also independently gave this theory in 1916. They had similar points. The similar points were, just see, Lewis postulated that an atom has two parts. He says that Bohr had already given his theory that, what did he say? He said there is nucleus, there are orbits, and the electrons are revolving around in the orbits. Lewis said that the nucleus along with the inner shell is called as kernel. It's called as kernel. And he said the outer shell, which is the valence shell, has electrons which are ready to react. So the inner part, the kernel, like you know, coconut. The inside part is kernel. It doesn't have anything to do with the outside world. And the outer shell will react. Now, this theory was very good in explaining the bonding at that time. But now we know that there are certain exceptions to the rule, and that some things are probably not as correctly explained. So the nucleus along with the inner shell is called as the kernel, and the outer shell is called as the valence shell, and it has electrons. He also said that any atom of the element has electrons. The valence shell has electrons arranged in a cubical manner. So let us say, if I talk about, let's say, lithium. Let us say, what is the atomic number of lithium? 3, right? So the atomic number of lithium is 3. What is the configuration? 1s2 and 2s1, right? So it has only one electron in the valence shell. So this one electron of the valence shell is present in the one of the corners of the cubical arrangement. Now, what lies below lithium in the alkali earth metals? Alkali metals? Sodium, right? So again, sodium also. What is the atomic number of sodium? 11. Again, what did he say? He said that the kernel, what is this part? This is the kernel, and this kernel is containing what? The nucleus as well as the inner shell electrons. The outer shell electrons are arranged in a cubical manner. So lithium, which has only valence shell 1 electron, it has 1 electron. Sodium will also have, what is the configuration? 281, or what do we say? 1s2, 2s2, 2p6 and 3s1. Again, the valence shell has only 1 electron. So you have kernel inside and you have a valence shell electron on the outside. Can you all write down in the cubical arrangement beryllium and magnesium? What is the atomic number of beryllium? 4. So what will be the configuration? 1s2, 2s2. Beryllium will be what? 1s2, 2s2. So valence shell has how many electrons? 2. Magnesium has, what is the atomic number? 12. 1s2, 2s2, 2p6 and 3s2. Again, the valence shell has 2 electrons. Except for the symbol name, they will both have the similar kind of arrangement according to the Lewis model. According to the Lewis model, the kernel is present inside, and both, whether we talk about beryllium or we talk about magnesium, they will have 2 electrons present in a cubical arrangement. So if I have, say, so which is the best arrangement according to Lewis? When we have, so cubical structure. So cubes में कितने corners है? 8 corners. और 8 corners किस में occupied रहे? Noble gases में. किस में occupied रहे? Noble gases में. So if I talk about neon, so how many electrons will be present in the valence shell? 8 electrons will be present in the valence shell, and all these 8 will occupy what? The corners of the cube, right? So according to him, the best arrangement will be when all the corners are occupied by the electrons. Okay, so according to him, the helium had some special characteristics. Lewis Causal had also said that same thing. Noble gases have some sort of stability and very good stability because of some reason. And similarly, they didn't explain why they had stability. They said they had a stable configuration. Similarly, Lewis also said that. Now just see, helium has 2 electrons in the valence shell, but it is also a noble gas and it has a stable configuration. So except for hydrogen, helium and lithium, most will try to achieve, the elements closer to helium will try to achieve the noble gas configuration of helium. The rest will try to achieve the noble gas configuration, any of the 3, and they all have 8 electrons in the valence shell. Okay, so now let's see what happens. So that means, we've already talked about this. So others will try to are reactive because they want to achieve some sort of stability, and that is done by either losing or gaining. Now, Causal and Lewis approach we've already did this. Now, Lewis had said kernel, outer shell electrons are arranged in a cubical manner. Now, this is what he said. He said 1s2, 2s1, and this is this, right? Now, how did they want to achieve the noble gas configuration? Well, he said, let me see, if I talk about chlorine, how many electrons will be there in the valence shell of chlorine? 7. Okay. So how will I draw the cubical arrangement of chlorine? How will I draw the cubical arrangement of chlorine? You have Lewis structure. You have a kernel. How many electrons on the valence shell? 7. Right. So 1, 2, 3, 4, 5, 6, 7. And this one is free. Is that okay? Now chlorine is able to form a Cl2 molecule. What did he say? He said you can achieve noble gas configuration by either loss of electron, gain of electron, or by sharing of electron. Anything is happy as long as they assume that this is ours. So another chlorine atom, chlorine molecule, let me draw. Sorry, my cube is not turning out to be cubical in nature, but we know. Okay, so this 1, 2, Sorry. Okay. Somehow I've drawn it wrong. Okay. Okay. This and right. This is free. I'm just saying just to show you the structure. So it has 7. One is free. This one is free. I've drawn all 8. Okay. In this also. This one is free and this one is free. So I have to make arrangements like this. Okay. So this one is free, this one is occupied. So this combines here and this combines here. So in this kind of arrangement, what is happening? Both the Cl2 molecules are able to achieve a noble gas configuration. This one was free, it is able to combine with the other one. This one was free and this was able to combine. So both have now, in fact, it is a joint structure and both have 8 electrons in their cubical arrangement. So Lewis had talked like this. So the 8 corners of the cube. Okay. So let's talk about what is the electronic theory of chemical bonding. So we've said Causal gave a different approach, Lewis gave a different similar. Causal and Lewis independently gave similar kind of approaches, and this was combined to give you a electronic theory of chemical bonding. Now in 1916, so what is it? The tendency of an atom to lose or gain electrons, either tendency to lose or gain or share is called as the is dependent upon the outermost shell electrons. It is called the valency. तो कितना आप lose करते हो? Suppose I have 2 electrons which I want to lose. So my valency is what? 2. In fact, when you were in smaller classes, you were told अगर 4 से कम electrons है, you will have a tendency to lose electrons. If you have more than 4 electrons, you will have tendency to gain electrons, right? So what happens? Because it's easier to do it. So tendency of an atom to take part in chemical combination depends upon the number of valence electron. तो कितना reactivity show कर रहा है उसके valence electrons पे depend करता है. So how can they take place? Sharing or losing or gaining. So this is called as the octet rule. What does the octet rule say? The atoms combine. What does the octet rule say? The atoms combine by mutual sharing or by transfer of 1 or more electrons. In doing so, each combining atom acquires the stable noble gas configuration having 8 electrons in its outermost shell. This is called as the octet rule. So anything to do to achieve the noble gas configuration is called as the what is the valency? Whether you can lose, how many electrons can you lose, gain, or you can share is called as the this is a little slow, sorry. Okay, so now suppose I'm talking about, now this was a different way. This was a cubical arrangement. Now let us, he also gave a very simple symbol. He talked about Lewis symbols. What are Lewis symbols? He said that let us, it's very difficult to draw cubical arrangement all the time. So what can we do? We can simply write the chemical symbol and the number of electrons in the valence shell. The symbol is representing the kernel along with the innermost shell electrons, and the outer shell electrons are represented by a dot. Let us, if you want to write for helium, there will be how many electrons in the valence shell? 2. Let us, sodium, there will be 1 dot. Can you talk, what about carbon? How many electrons will be there? So you have a chemical symbol of C. How many electrons on the valence shell? 4. And this is the Lewis dot symbol representation for the carbon. Now, I've said this 4 is representing its valency. So what is the valency of carbon? 4. What is the valency of helium? 2. So the valency is either the number of electrons in the outermost shell, or is it 8 minus the number of electrons in the outermost shell? I have explained to you. अगर 4 से कम है, तो मैं क्या करूँगी? I would prefer to lose 1 electron or 2 electrons or 3 electrons and try to achieve the innermost shell noble gas configuration, right? So if I have lithium, I have 1 electron in the outermost shell. It's so easy to lose just 1 electron, खो दिया. और अंदर क्या है मेरे पास? कौन सी noble gas configuration है? Helium की. अगर मैं सोडियम हूँ, मेरे पास 1 इलेक्ट्रॉन वैलेंस शेल में है, तो मैं क्या करूंगी, मैं 1 इलेक्ट्रॉन क्लोरीन जिसके पास कितने इलेक्ट्रॉन्स है वैलेंस शेल में, 7 है, उसको दे दूंगी और अपने कौन सी कॉन्फ़िगरेशन अचीव कर लूंगी, नियॉन की, और इसकी कौन सी हो जाएगी, आर्गन की. सो दिस बिकम्स Cl माइनस एंड दिस बिकम्स Na प्लस. सो दिस वे इट इज वेरी इजी टू डू दैट. अगर मेरे पास इसमें देखो सोडियम के पास 1 इलेक्ट्रॉन था और क्लोरीन के पास मोर जस्ट 1 इलेक्ट्रॉन लेस देन दी noble gas configuration. So we've talked about. So these are the various Lewis dot structures for various compound. Now, just see. Lithium fluoride में क्या हुआ? Lithium has 1 electron in the outermost shell. It loses to the fluorine. Fluorine becomes F minus, and lithium becomes what? Li plus. Okay. In the next B. अच्छा, can you talk about the compound formation in B? B में देखो, B में कितने electrons हैं in the valence shell? What is the atomic number? 4. So it has 2 electrons in the outermost shell. It's so easy to lose those 2 electrons. 1 electron it loses to fluorine, the other to another fluorine. So both the fluorines achieve their noble gas configuration, that is 8 electrons in the outermost shell, and B achieves the duple, which is the helium configuration. So B becomes Be2 plus, fluoride F becomes F minus, and the F becomes F minus. So, but why? Now you will think, why are we studying such? Why do we want to study Lewis dot structures? When you are doing valence shell electron pair repulsion theory, whenever you are doing resonance, you have to draw structures. Structures बनाने के लिए, वो जो structures हम बनाते हैं, आज भी बनाते हैं, जो structural formulas आप बनाते हैं, उनके लिए आपको क्या है, वो structural formulas बने कैसे, वो सब बने लुईस डॉट स्ट्रक्चर से. तो लुईस डॉट स्ट्रक्चर्स की इतनी इंपॉर्टेंस है कि अगर आपको लुईस डॉट स्ट्रक्चर नहीं पता तो आपको ये नहीं पता चलेगा कि आपके ऑर्गेनिक लंबी लंबी चेन्स कैसे बनी. आपके वो जो स्ट्रक्चर्स हैं, जैसे अगर आपका PCl5 है तो PCl5 कैसे बना, तो लुईस के स्ट्रक्चर देने से हमें एक आइडिया हो गया था कि इस तरह के बॉन्ड्स बनेंगे. Obviously it was not able to explain all the structures and it did not talk about the shapes at all, but it was able to give you some sort of bonding idea. Is that okay? Right. So now when we like in the case of sodium chloride, आपके पास सोडियम आया, आपके पास क्लोराइड आया, दोनों की नोबल गैस कॉन्फ़िगरेशन होगी, एक केटायन है और एक एनायन है. इनके बीच में कौन सी फोर्सेस ऑफ अट्रैक्शन होगी, इलेक्ट्रो व्हाट आर दे कॉल्ड एज कूलम्बिक फोर्सेस ऑफ अट्रैक्शन. क्या कहलाती है, कूलम्बिक फोर्सेस ऑफ अट्रैक्शन. अब मेरे पास एक केटायन है, एक सर्कुलर. जब केटायन हो या एनायन हो, किसका साइज बड़ा होगा, किसका छोटा, केटायन का स्मॉल होगा, एनायन का बड़ा होगा. राइट, हमेशा नॉर्मली ऐसे ही होता है. तो केटायन का स्मॉल साइज है और एनायन है. अब दोनों स्फेरिकल इन नेचर है, तो मेरे इस केटायन के चारों तरफ मतलब इन अ स्फेरिकल नेचर मेरे पास एक पॉजिटिव स्फीयर है, पॉजिटिव इलेक्ट्रोस्टैटिक फोर्स ऑफ अट्रैक्शन है. क्लोराइड के चारों तरफ नेगेटिव फोर्स. तो दोनों जब आते हैं तो उनके बीच में एक कूलम्बिक फोर्सेस ऑफ अट्रैक्शन हो सकती है. एक इंपॉर्टेंट चीज है, क्या ये डायरेक्शनल होती है, कूलम्बिक फोर्सेस ऑफ अट्रैक्शन डायरेक्शनल होंगी. देखो ये मेरा सोडियम है, मेरा इस सोडियम के चारों तरफ पॉजिटिव फील्ड है, तो क्लोराइड मेरा, मैंने यहां लिखा है ये क्योंकि मेरे को लिखने का मन था, बट क्लोराइड कुड कम एनीवेयर अराउंड द सोडियम and it could come here, it could come here, it could come here, because it is a spherical coulombic forces of nature. तो मेजर इंपॉर्टेंट बात क्या है इलेक्ट्रोवैलेंट बॉन्ड की या आयनिक बॉन्ड की, कि ये कैसा होता है, नॉन डायरेक्शनल होता है. कैसा होता है, नॉन डायरेक्शनल. और इसको हमने बनाया कैसे, because we wanted to lose or gain electron to achieve the noble gas configuration. Right, okay. So okay. Okay, let's say calcium fluoride. In the case of calcium fluoride, calcium में क्या है? What is the configuration? Argon 4s2, 2 electrons on the valence shell. It loses those 2 electrons, becomes Ca2 plus. Fluorine, it has 1 electron less in the noble gas configuration. Helium 2s2 2p5. कैल्शियम ने अपने 2 इलेक्ट्रॉन्स लूज करे, एक इलेक्ट्रॉन एक फ्लोरीन ने एक्सेप्ट करा, दूसरा इलेक्ट्रॉन दूसरे फ्लोरीन ने एक्सेप्ट करा. सो यू हैव 2F which are accepting 1 electron each. So you have calcium and 2 fluoride combining to give you a CaF2. कैसी फोर्सेस है इसके अंदर, electrostatic forces of attraction या coulombic forces of attraction. Okay. Now, now we are talking about causal Lewis approach. The causal and Lewis approach basically start with the ionic bonding से. Langmuir ने इसको modify करा और उसको थोड़ा सा आगे बढ़ाया and he said he talked about covalent bonding. So Lewis ने अपने टाइम में खाली क्या explain करा था? Ionic structures के बारे में बात करी. तो Langmuir ने कहा octet rule is valid. You are already talking about sharing of electrons. So Langmuir said that when you're talking about sharing of electrons, that means there is a sort of different kind of bonding which is taking place. That kind of bonding he called as covalent bond. So what is the Lewis-Langmuir theory? He said that covalent bonds are formed by sharing of electrons. Can you see here? Chlorine has how many electrons in the valence shell? 7. Chlorine has how many electrons in the valence shell? 7. अगर each chlorine दूसरे क्लोरीन के साथ शेयरिंग करता है तो शेयरिंग का मतलब क्या है सपोज आई हैव अ पेन एंड माय फ्रेंड हैज अ पेन राइट एंड वी बोथ वांट टू स्टडी टुगेदर बट समहाउ वी डोंट हैव सो व्हाट आर वी डूइंग वी आर शेयरिंग द पेन बिटवीन अस एंड using it whenever we are needed, right? So I am happy that I have a pen, my friend is happy I have a pen. So in the case of chlorine also, both the combining atoms, what are the combining atoms? Chlorine. Each chlorine is contributing 1 electron to the bonding and both electrons are and they're also getting 1 electron from the other. So दोनों के पास क्या हो एक देने से दूसरा free मिला, buy one get one free types ना, तो shared one and got one free. तो उसके साथ क्या हुआ आपके पास एक बॉन्ड बना तो शेयरिंग ऑफ 1 इलेक्ट्रॉन पेयर टेक्स प्लेस. याद रखें कि कोवेलेंट बॉन्ड में जब whenever one sharing of 1 electron pair takes place, each of the combining atoms are contributing 1 electron, right? So क्लोरीन के पास नियॉन 3s2 3p5 कॉन्फ़िगरेशन थी, उसने एक इलेक्ट्रॉन दूसरे इलेक्ट्रॉन क्लोरीन के साथ लिया और उसके पास कॉन्फ़िगरेशन क्या होगी 3s2 3p6 which is that of argon. Okay. So, the covalent bond, how are the covalent bonds formed? Sharing of electrons. Again, यहाँ पे भी valency वही रही. For example, let us say, I want to talk about methane. Let us talk about methane. Methane के लिए जब भी हमें Lewis dot structure लिखने होते हैं, सबसे पहले तो हमें symbols पता होने चाहिए. अगर हमें symbols ही नहीं पता होंगे और atomic इलेक्ट्रॉनिक कॉन्फ़िगरेशन ही नहीं पता होगी तो हम किसी का ल्यूइस डॉट स्ट्रक्चर लिख ही नहीं सकते. सो सबसे पहली बात हमने बात करी मीथेन की, राइट? सो वी आर टॉकिंग अबाउट कार्बन. कार्बन इज बीइंग द सेंट्रल एटम. हाउ मेनी इलेक्ट्रॉन्स आर देयर इन द वैलेंस शेल? 4 इलेक्ट्रॉन. व्हाट अबाउट हाइड्रोजन? हाइड्रोजन हैज 1 इलेक्ट्रॉन इन द वैलेंस शेल. Hydrogen will achieve what kind of noble gas configuration? Helium. It needs 2 electrons to achieve the noble gas configuration. So what does it do? Carbon, all its 4 electrons are shared with hydrogen. So each hydrogen contributes 1 electron and carbon also is contributing 1 electron. Similarly, this hydrogen has contributed 1 electron and the carbon has contributed 1 electron. Similarly, this hydrogen has contributed 1 electron, carbon has 1 electron. So in this case, just see, this carbon had how many electrons in the valence shell? 4. By sharing 4 electrons with the 4 hydrogens, it has now got 8 electrons in the valence shell. Carbon is happy, I have got 8 electrons in the valence shell. Hydrogen is happy, I have got a duplet in my valence shell. So in the sharing, the contributing atoms both get the electrons and that is the advantage of the, okay. Now you can also have 2 electron bonds which can be 2 electron pairs which can be shared. You can have 3 electron pairs which can be shared. For example, this kind of structure, so this is called as the structural formula. ये क्या कहलाता है आपका structural formula. और ये structural formula में ये जो stick है, that is denoting the single bond and that means 2 electrons. Now let us say I have let us talk about ethene. I don't know how many of you know that. This is the structural formula of ethene. How do we get that? Each carbon has how many electrons in the valence shell? 4. So both the carbons contribute 2 electrons to the bonding between them. And they also share 1 electron pair with the hydrogen. So 2 hydrogens on each carbon. So इस कार्बन के पास कितने इलेक्ट्रॉन्स थे? 4 थे. इसने एक हाइड्रोजन के साथ शेयर करा, एक दूसरे हाइड्रोजन के साथ शेयर करा. सॉरी, मैंने इसको यहां बनाना है. उसने बाकी क्या किया? उसने अपने 2 इलेक्ट्रॉन्स किस कार्बन के साथ शेयर करे? बगल वाले कार्बन के साथ शेयर करे. तो अब उसके पास कितने इलेक्ट्रॉन्स आ गए? 4 इलेक्ट्रॉन्स. कितने आ गए? 4 बीच में. और ईच हाइड्रोजन से एक एक रिसीव करने से उसके पास कितने हो गए? 8 इलेक्ट्रॉन्स इन द बैलेंस स्टेट. सिमिलरली दिस कार्बन, इसने 2 कंट्रीब्यूट करे टू द बॉन्ड फॉर्मेशन विद द कार्बन. इसने अपने एक एक इलेक्ट्रॉन्स को हाइड्रोजन के साथ शेयरिंग में डाला और इसके पास बन गया इस तरह का स्ट्रक्चर. तो इसमें क्या हुआ? ये जो 2 इलेक्ट्रॉन पेयर्स हैं, दे आर 1 इलेक्ट्रॉन पेयर इक्वल्स टू 1 बॉन्ड, 2 इलेक्ट्रॉन पेयर्स इज इक्वल टू 2 बॉन्ड्स. सो दिस इज कॉल्ड एज डबल बॉन्ड. तो इसके बीच में कार्बन और कार्बन के बीच में क्या आ गया? डबल बॉन्ड. कार्बन एंड हाइड्रोजन के बीच में क्या है? सिंगल बॉन्ड्स. क्या कार्बन हाइड्रोजन के बीच में डबल बॉन्ड आ सकता है? नो, बिकॉज यू कांट go beyond. So the Lewis dot structures have an importance in the sense that if you don't have the Lewis dot structures, you will not be able to draw some sort of structure. Okay. So just see these examples. हाइड्रोजन के पास एक एक इलेक्ट्रॉन था, शेयर करेगा हीलियम की कॉन्फ़िगरेशन के लिए, तो उसके पास क्या आ जाएगा? H2 मॉलिक्यूल. हीलियम 2 नहीं बनता. क्यों नहीं बनता? इसी रीजन से नहीं बनता. क्लोरीन ने एक एक इलेक्ट्रॉन शेयर करा. Each chlorine gets an octet in its valence shell. Let's talk about nitrogen. Okay, let's talk about nitrogen. कितने इलेक्ट्रॉन्स है वैलेंस शेल में नाइट्रोजन के? 5 इलेक्ट्रॉन्स है इन द वैलेंस शेल. उसको कितने इलेक्ट्रॉन चाहिए नोबल गैस कॉन्फ़िगरेशन के लिए? 3. तो मुझे 3 चाहिए, तो मुझे देने भी कितने पड़ेंगे? 3. तो मैं 3 दूंगी तो 3 मुझे मिलेंगे, और मेरे पास 3 को छोटे बच्चे कितने? 2, और +3 कितने हो गए? 6. सो 6 + 2 हो गए 8. सो नाइट्रोजन ने अपने, उसके पास थे 5, और उसने क्या किया? अपने 3 इलेक्ट्रॉन्स, कितने इलेक्ट्रॉन्स? 3 इलेक्ट्रॉन्स जो है दूसरे नाइट्रोजन के साथ बॉन्डिंग में लगा दिए. और उसके पास बच कितने गए? 3 उसने कंट्रीब्यूट करे तो बचे कितने? 2. तो ये जो बचे हैं इनको कहते हैं हम लोन पेयर्स और नॉन बॉन्डिंग इलेक्ट्रॉन्स. दे आर सो कॉल्ड एज नॉन बॉन्डिंग इलेक्ट्रॉन्स. Okay, so both the nitrogens are left with 1 electron pair, which is a non-bonding pair. अब इसको देखो, इस नाइट्रोजन के पास क्या हो गए? 1 2 3 देने से 3 आए, और उसके पास पहले से 2 थे तो 8 हो गए. Similarly, this nitrogen, it contributes 3, gets 6 + 2, so 8. So nitrogen has triple bond formation and 1. So ये जो bonding electron pairs जो shared हुए, these are called as shared pair of electrons or bonding pair of electrons. These are called as lone pairs, or they are called as non-bonding pair of electrons. Is that okay? Okay. So let me see how many of you can draw good structures. Before, let's just practice एक दो structures के साथ. मीथेन के साथ मैं आपको बता ही चुकी हूँ कि कार्बन के पास 4 इलेक्ट्रॉन थे. कार्बन के पास कितने इलेक्ट्रॉन्स थे? 4. उसके पास 4 हाइड्रोजन्स आए टू मेक ईच अदर हैप्पी. उनको क्या चाहिए था? लोअर एनर्जी. बट प्लीज याद रखिएगा, एटम्स की हायर एनर्जी होती है एज कंपेयर टू मॉलिक्यूल्स. किसकी एनर्जी कम होती है? मॉलिक्यूल्स. तो मॉलिक्यूल्स बने ही इसलिए क्योंकि वी वांटेड टू लोअर द एनर्जी. सो ओके, सो चारों कार्बन ने सॉरी, इट्स गॉट स्लो. ओके, वो कार्बन के चारों इलेक्ट्रॉन्स शेयर्ड हो गए विद द हाइड्रोजन, एंड यू गेट अ ऑक्टेट इन द. ओके, लेट्स सी SeF2. सेलेनियम किस ग्रुप में आता है बेटा? इट्स इन द सेम ग्रुप एज, हाँ, 16. ऑक्सीजन वाली फैमिली को बिलोंग करता है. so इसकी वैलेंस शेल में कितने इलेक्ट्रॉन्स है? 6. इसको कितने चाहिए नोबल गैस कॉन्फ़िगरेशन अचीव करने के लिए? 2. सो उसने क्या किया? फ्लोरीन के साथ SeH2 भी बनता है और SeF2 भी बनता है. फ्लोरीन को एक एक इलेक्ट्रॉन चाहिए, तो कोई वो बड़ी जल्दी खुश हो जाते हैं. एक इलेक्ट्रॉन एक फ्लोरीन को दिया, एक इलेक्ट्रॉन दूसरे फ्लोरीन को दिया, और आपके पास क्या होगी? नोबल गैस कॉन्फ़िगरेशन अचीव होगी सेलेनियम के पास, और फ्लोरीन्स के पास भी अचीव होगी. Okay, so just a quick check. Can all of you answer? आप अपने अपनी कॉपीज में आंसर करो. Let's see how many of you get a good answer. Ionic bonds are formed between a, very good, a metal atom dash an electron to form while a non-metal, very good. Two oppositely charged ions to form a, okay, an anionic form bond is formed by the, अच्छा चलो नीचे वाला देखो, is aluminum oxide an ionic or a covalent compound? Aluminum oxide का formula, very good, okay. So solution क्या है इसका? आप मेरे ख्याल से आप सबने सारे सही करे. Can you reduce the volume, बंद खत्म कर दीजिए, sound खत्म कर दीजिए. Okay, okay. It's not going. Sound नहीं बंद किया आपने. Right, okay. 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 हमारा solution क्या है? Ionic bonds are formed between a metal and a non-metal. A metal loses an electron to form a positive ion. A non-metal gains an electron to form a negative ion. Two oppositely charged ions attract each other to form an ionic bond. Ionic bond is formed by the transfer of electrons. ये तो इसका आंसर भी आ गया. चलो, anyways, you know, the joining of atoms to form a molecules is called as a covalent bonding. Two types of bonds are covalent bonds and ionic bonds. Covalent bonds are formed by the sharing of electrons. Ionic bonds are formed by the transfer of electrons, and covalent bonds are formed between non-metals. That's important. तो मेरे मीथेन जो बना वो कैसे बना? Non-metals के कारण बना. किसके कारण बना? Non-metals के. Carbon dioxide. Can you write down the Lewis dot structure of carbon dioxide? Can everyone write down the Lewis dot structure of carbon dioxide? Carbon dioxide is an ionic compound or a covalent compound? Covalent, right. So ionic covalent compounds are always formed between non-metals. कर लिया? अच्छा. So आपने कितने इलेक्ट्रॉन पेयर शेयर कराए दोनों कार्बन और ऑक्सीजन के बीच में? Double bond, right. Did everyone get that? Okay. So कार्बन के पास कितने इलेक्ट्रॉन थे? 4. तो उसने दो इलेक्ट्रॉन्स किसके साथ शेयर करे? ऑक्सीजन के साथ. ऑक्सीजन के पास कितने इलेक्ट्रॉन्स थे? 6. तो जैसे ही उसने अपने 6 इलेक्ट्रॉन में से 2 शेयर करने को डाले तो उसके पास क्या हो गया? अचीव ऑक्टेट. और कार्बन ने अपने 2 डालने से क्या हो गया उसके पास? अचीव ऑक्टेट. अच्छा, अब मुझे इसमें ये बताइए, इसमें नॉन बॉन्डिंग इलेक्ट्रॉन पेयर्स कितने हैं? ऑक्सीजन के पास कितने नॉन बॉन्डिंग इलेक्ट्रॉन पेयर्स है? 2 है. पेयर्स हम पूछ रहे हैं, किसकी बात कर रहे हैं? पेयर्स की बात कर रहे हैं. ओके, दिस वी हैव डन. ओके, this we've done. Is there anything that you want to ask right now? कोई questions तो नहीं आए इस समय? This I was told. Okay. Yes. This is a question that using electron dot structure, can we state a molecule whether it is an acid, base, or neutral molecule? Okay. Can anyone help me with this? Can we state whether the molecule is an acid, base, or a neutral molecule? Now see, we've done various kinds of acids and bases. तो हम Lewis acid and base का concept हमने पढ़ा है. Lewis acid and bases में क्या होता है? आपने सिंपल एसिड्स एंड बेसिस करा था प्रोटॉनिक थ्योरी के अकॉर्डिंग. प्रोटॉन देता है, प्रोटॉन हाइड्रोक्साइड देता है. एक होता है, आपने ब्रॉन्स्टेड लॉरी एसिड बेस थ्योरी पढ़ी होगी, जिसमें प्रोटॉन देता है और प्रोटॉन एक्सेप्ट होता है. ल्यूइस एसिड बेस थ्योरी में क्या है? इलेक्ट्रॉन डोनर्स एंड इलेक्ट्रॉन एक्सेप्टर्स. सो व्हिच आर इलेक्ट्रॉन डोनर्स? व्हाट आर द इलेक्ट्रॉन डोनर्स कॉल्ड एज? Bases. And what are the electron acceptors called as? Acids. Okay. So can we from the Lewis structure know whether there is an acid base? Yes, no? If we have a non-bonding pair of electrons or the lone pair of electrons present, that means it can act as a Lewis base. For example, let us say ammonia is there, right? We already know ammonia is basic in nature, but the Lewis according आता कि basic? बताइए, अमोनिया में क्या है? मैंने आपको बताया नाइट्रोजन हैज 5 इलेक्ट्रॉन पेयर्स. 3 उसने हाइड्रोजन के साथ शेयर किया, उसका ऑक्टेट अचीव हो जाता है. उसके पास बचा क्या? अ लोन पेयर. दिस लोन पेयर इज रिजल्टिंग इन द फॉर्मेशन ऑफ This is acting as a Lewis base. It is acting as a Lewis base. ठीक है? What about एक्सेप्टर कौन सा होगा? जिसने किसी तरह अपना मॉलिक्यूल तो बना लिया, पर उसके बाद स्टिल देयर इज अ स्पेस टू एक्सेप्ट एन इलेक्ट्रॉन पेयर. तो ऐसा कौन सा हो सकता है जिसने ऑक्टेट नहीं अचीव करा बट मॉलिक्यूल बना लिया? फॉर एग्जांपल, कैन एनीवन टॉक अबाउट BF3? Can you write down the structure? How many electrons are there in the valence shell of boron? 3 electrons in the valence shell. How many electrons is it getting from fluorines? 3. So boron के पास कितने valence shell में आए? 3 उसने खुद के दिए, 3 receive किए fluorine से, and it has 6. It's still 2 electrons short of the noble gas configuration, but it is quite stable molecule. So what does it do? It can still accept 1 electron. So ammonia, there's a very important, this kind of bonding is actually called कोऑर्डिनेट बॉन्डिंग. कि अमोनिया ने अपना एक लोन पेयर किसको दिया? BF3 को, और एक कॉम्प्लेक्स बन गया, कोऑर्डिनेट बॉन्ड बन गया. क्या बन गया? सो क्या हमें पता चला है एसिड और बेस होते हैं? ल्यूइस एसिड्स एंड ल्यूइस बेसिस का जो कांसेप्ट है वो हमें पता लगता है फ्रॉम लुईस डॉट स्ट्रक्चर्स. लोन पेयर है तो दैट मींस इट इज अ बेस. लोन पेयर एक्सेप्ट कर सकता है तो इट इज अ एसिड. इज दैट ओके? And this donor acceptor. So ये क्या हो गया? Donor, और ये क्या हो गया? Acceptor. Okay. ये वैसे मैं इसके बारे में बात भी करने वाली हूँ. Okay. Now we've done ionic bonds, covalent bonds. So ionic compounds and covalent compounds भी तो हमें पता होने चाहिए ना? So basically you all have an idea. In the ionic compounds we have strong electrostatic forces of attraction which are non-directional in nature. कैसी है वो? Non-directional है. इन forces के कारण इनके melting points बहुत high होते हैं. And बॉइलिंग पॉइंट्स भी बहुत हाई. तो सोडियम क्लोराइड का मेल्टिंग पॉइंट करीब 800 केल्विन से ऊपर का है. कोवेलेंट कंपाउंड्स नॉर्मली मोस्ट कोवेलेंट कंपाउंड्स का मेल्टिंग पॉइंट लो होता है एंड बॉइलिंग पॉइंट क्या होता है? लो. एक्सेप्ट फॉर एक्सेप्शंस लाइक डायमंड. डोंट टॉक अबाउट डायमंड टू मी. बट कोवेलेंट कंपाउंड्स का नॉर्मली क्या होगा? लो मेल्टिंग एंड लो बॉइलिंग पॉइंट. ओके. आयनिक कंपाउंड्स अगर आप NaCl लेते हैं, घर में जो नमक होता है, अगर आप उसमें से इलेक्ट्रिसिटी वैसे पास करने की कोशिश करें तो नहीं पास करेगी. इन द बिकॉज सोडियम क्लोराइड, बिकॉज याद रखें जब आयनिक कंपाउंड्स बनते हैं तो क्या हुआ? आपका सोडियम आयन था, क्लोराइड आयन था, ये कैसे अरेंजमेंट में होता है? एक FCC टाइप का अरेंजमेंट, लैटिस आती है. क्या बनता है? लैटिस. एक सॉलिड लैटिस बनता है. इस फ्रेमवर्क के कारण आयनिक कंपाउंड्स बनते हैं. इनके अंदर बहुत स्ट्रॉन्ग फोर्सेस ऑफ अट्रैक्शन होती है, राइट? तो ये सॉलिड नेचर में इलेक्ट्रिसिटी कंडक्ट नहीं करते. पर अगर किसी तरह से आपने आयंस अलग कर दिया, और आयंस तो क्या करते हैं? कंडक्ट, इलेक्ट्रिसिटी कंडक्ट करते हैं. तो या तो मैं इसको ब्रेक कर दूं, मोल्टन सोडियम क्लोराइड ले लूं, या मैं इसको पानी में डिसॉल्व कर दूं, और डाइलेक्ट्रिक कांस्टेंट ऑफ वाटर विल सेपरेट द आयंस. तो ये इलेक्ट्रिसिटी कंडक्ट करने लगेंगे. व्हाट अबाउट कोवेलेंट कंपाउंड्स? नहीं. क्यों नहीं? क्योंकि क्लोरीन जो है, लेट अस टॉक अबाउट क्लोरीन. क्लोरीन में क्या हुआ? बॉन्ड फॉर्मेशन हुआ. बॉन्ड फॉर्म हो गया. ये कैसा बॉन्ड है? डायरेक्शनल बॉन्ड है. जो शेयर्ड पेयर ऑफ इलेक्ट्रॉन्स है वो दोनों एटम्स के बीच में. सो ये क्लोरीन और एक ये क्लोरीन है, और इनके बीच में शेयर्ड पेयर ऑफ इलेक्ट्रॉन्स. सो ये शेयर्ड पेयर बीच में है, तो इसका क्या है? एक डायरेक्शन है, राइट? बॉन्ड बन गया. ये बॉन्ड रिलेटिवली स्ट्रॉन्ग होता है, पर उतना जितना आयनिक है उतना नहीं होता है, तभी मेल्टिंग पॉइंट्स लो है. It cannot conduct electricity because ions तो है ही नहीं. इलेक्ट्रिसिटी कैसे कंडक्ट करेगा? अब फिर आप पूछेंगे ग्रेफाइट. तो ग्रेफाइट इज एन एक्सेप्शन. उसमें क्या होता है? शीट स्ट्रक्चर होता है. 3 इलेक्ट्रॉन्स तो क्या यूज हो जाते हैं? शीट्स बनाने के लिए. कार्बन, और एक इलेक्ट्रॉन जो फ्री होता है वो 2 पेयर्स लेयर्स के बीच में होता है, जिसके कारण वो इलेक्ट्रिसिटी कंडक्ट. सो इट इज एन एक्सेप्शन. दीज आर सर्टेन एक्सेप्शंस. हर चीज के एक्सेप्शंस तो होंगे. सो ionic compounds are usually soluble in water, but these will be insoluble in water. तो मीथेन एंड वाटर अगर आप दोनों को साथ रखें तो दोनों अलग अलग लेयर्स. मीथेन तो गैस ही होती है. सॉरी, लेट्स टॉक अबाउट साइक्लोहेक्सेन और आपने वाटर को साथ साथ रखा तो वो अलग अलग लेयर्स बनाएंगे. इज दैट ओके? सो दैट इज डन. अब हम लुईस डॉट स्ट्रक्चर्स का लास्ट, बिकॉज दिस इज वेरी इंपॉर्टेंट. ओके, we'll do this later, not important for me right now. Let's talk about coordinate bond. So Till now we have talked about ionic bond. Ionic bond के बाद covalent bond का concept किसने डाला? Langmuir ने डाला. फिर Perkin-Elmer reaction, Perkin condensation, बहुत सारे organic का सारा काम majorly start Perkin के time पे हुआ. So he gave a related type of bond formation which is called as coordinate bond formation. Now coordinate bond formation जैसे मैंने अभी आपको बताया ammonia and BF3 के केस में आजकल in the present day कोऑर्डिनेट बॉन्ड एंड कोवेलेंट बॉन्ड में कोई फर्क नहीं है. आज की प्रेजेंट डे में आज हम कहते हैं कि कोऑर्डिनेट बॉन्ड इज इक्विवेलेंट टू अ कोवेलेंट बॉन्ड. ऑल्दो कोऑर्डिनेट बॉन्ड कैसे बना है? बाय डोनेशन ऑफ एन इलेक्ट्रॉन पेयर बाय वन ऑफ द कंबाइनिंग एटम्स. सो यहाँ पे देखिए कंबाइनिंग एटम आपके कौन से हैं? हम एन एंड पी, पर इलेक्ट्रॉन दिया किसने? नाइट्रोजन ने, नॉट बी ने. सो कोवेलेंट बॉन्ड में क्या था? ईच ऑफ द कंबाइनिंग एटम्स इज गिविंग वन इलेक्ट्रॉन, बट इन अमोनिया only one is giving you the electron pair. But वो electron pair present के बीच में होगा, दोनों के बीच में ही होगा. तो that is why आजकल हम coordinate covalent bond कहते हैं. या normally actually कोई फर्क नहीं है coordinate bond में और covalent bond में, except कि ये बना कैसे था. कैसे बना है ये? By donation of an electron pair by one of the combining atoms and not by both, right? So just see the example of carbon monoxide. कैसे कार्बन मोनोऑक्साइड में क्या हुआ? कार्बन डाइऑक्साइड तो बड़ा सिंपल था, अभी हमने करा. कार्बन डाइऑक्साइड में क्या हुआ? बोथ द ऑक्सीजन गिव 2 इलेक्ट्रॉन पेयर्स और डबल डबल बॉन्ड बन गया और आपका कार्बन डाइऑक्साइड बन गया. क्या बन गया? कार्बन डाइऑक्साइड बन गया, है ना. ऑक्सीजन के पास 2 क्या बच गए? लोन पेयर्स बन गए. ठीक है. कार्बन मोनोऑक्साइड कैसे बनेगा? CO. देखो ये तो मैंने नीचे बनाया हुआ है, बट कैन एनीवन एक्सप्लेन टू मी व्हाट हैव आई डन? What have I done here? This is coordinate bond. कैसे बना? कौन सा coordinate bond लगा दिया हमने यहाँ पे? कार्बन एंड ऑक्सीजन है. कार्बन एंड ऑक्सीजन है. कार्बन कितने इलेक्ट्रॉन दे सकता है एक टाइम पे? 4 तो नहीं दे सकता. एक साथ सारे तो नहीं दे देगा ना शेयरिंग के लिए. तो 3. तो आप उसने कितने दिए? 3 इलेक्ट्रॉन्स कंट्रीब्यूट करे. तो क्या उसे 8 मिल जाने वाला आसानी से? नहीं मिलने वाला ना. उसका तो 8 अचीव हो जाएगा, पर ऑक्सीजन क्या हो जाएगा? 8 से बढ़ जाएगा. 8 का क्या हो जाएगा? एक्सीड कर जाएगा. सो ये भी नहीं हो सकता कि कार्बन अपने 3 दे दे. जैसे इसने बोला कार्बन 4, 3 से ज्यादा नॉर्मली कोई देता नहीं है. 4 क्यों देगा भाई? हाँ 3 दिया. अब सपोज 3 दिया कार्बन ने, तो कार्बन को 3 मिल गए, उसका ऑक्टेट कंप्लीट हो जाएगा. पर ऑक्सीजन का क्या होगा? ऑक्सीजन का क्या हो जाएगा? एक्स्ट्रा हो जाएगा. वी डोंट वांट दैट टू हैपन. सो क्या होता है? कार्बन क्या करता है? कार्बन अपने खाली 2 इलेक्ट्रॉन्स देता है. जब कार्बन ने 2 दिए तो ऑक्सीजन ने भी कितने दिए? 2. तो इनके बीच में 2 तो सिंगल, मतलब 2 तो कोवेलेंट बॉन्ड्स खाली नॉर्मल शेयरिंग से हो गए. पर अभी भी कार्बन का ऑक्टेट अचीव नहीं हुआ. तो ऑक्सीजन क्या करता है? अपना इलेक्ट्रॉन पेयर जेनरोसिटी में किसको कंट्रीब्यूट करता है? टू द बॉन्डिंग. सो ये इलेक्ट्रॉन पेयर कहां से आया? ऑक्सीजन से. कार्बन ने कंट्रीब्यूट कितने किए थे? 2. तो ऑक्सीजन ने भी कितने कंट्रीब्यूट करे कोवेलेंट बॉन्डिंग के लिए? 2. पर एक इलेक्ट्रॉन पेयर है, अभी भी कार्बन का ऑक्टेट कंप्लीट नहीं हो रहा था. तो कार्बन मोनोऑक्साइड तो बनती है. तो कार्बन मोनोऑक्साइड बनने के लिए क्या हुआ? ऑक्सीजन ने अपना एक इलेक्ट्रॉन पेयर जो कि उसके पास फ्री बैठा हुआ था, उसने अपना नॉन इलेक्ट्रॉन पेयर कार्बन के शेयरिंग में लगा दिया. तो अब कार्बन के पास कितने हो गए? 8. और ऑक्सीजन के पास तो वैसे ही 8 आराम से हो गए. उसने अपना नॉन बॉन्डिंग शेयरिंग के लिए दिया, पर जेनरोसिटी में दिया. राइट. सो कार्बन मोनोऑक्साइड में क्या हुआ? कार्बन के पास भी एक लोन पेयर बच गया, ऑक्सीजन के पास भी लोन पेयर बच गया और 3 का बॉन्ड बन गया. इनफैक्ट कार्बन मोनोऑक्साइड का स्ट्रक्चर पता है कैसे लिखते हैं? अगर पहले नॉर्मली हम कोऑर्डिनेट बॉन्ड्स ऐसे रिप्रेजेंट करते थे, पर आजकल हम ऐसा नहीं करते, क्योंकि हम कहते हैं कोऑर्डिनेट बॉन्ड्स एंड कोवेलेंट बॉन्ड्स में कोई फर्क नहीं होता. ठीक है. तो फिर हम इसलिए ऐसे भी लिख सकते हैं. अंडरस्टूड? हैव यू अंडरस्टूड दैट कांसेप्ट? ओके. ओके. सो मैंने आपको बताया ल्यूइस एसिड बेस का कॉन्सेप्ट. अमोनियम आयन. अमोनिया के पास ऑलरेडी 8 इलेक्ट्रॉन्स है, पर एक लोन पेयर बचा हुआ है. Do you have a lone pair left? A proton is present alone. So, lone pair is contributed to H. Positive charge is shared equally by the whole molecule now. नाइट्रोजन ने अपना लोन पेयर कोऑर्डिनेट बॉन्ड में लगाया और उसके पास क्या आ गया, एक पूरे मॉलिक्यूल के पास क्या, पूरे आयन के पास क्या आ गया, सिंगल पॉजिटिव चार्ज. जैसे मैंने अमोनिया का BF3 के साथ बताया वैसे ही AlCl3 के साथ बताया. एल्यूमिनियम में भी वैलेंस शेल में कितने इलेक्ट्रॉन्स होते हैं, 3 शेयरिंग से लिए भी तो भी उसके पास 2 इलेक्ट्रॉन शॉर्ट थे, तो एक लुईस एसिड बन जाएगा और एक लुईस बेस बन जाएगा एंड आपके पास इस तरह का सॉल्ट फॉर्मेशन हो जाता है, राइट. तो ये कोऑर्डिनेट बॉन्ड्स है. तो अब हमें लुईस स्ट्रक्चर्स, अब हमने इतना सारा पढ़ा, कोऑर्डिनेट बॉन्ड, कोवेलेंट बॉन्ड. प्लीज जस्ट रिमेंबर द कोऑर्डिनेट बॉन्ड्स आर सेम एज कोवेलेंट, बट देयर इज नो डिस्टिंग्विशिंग कैरेक्टर फ्रॉम द कोऑर्डिनेट. ओके, सो लुईस डॉट स्ट्रक्चर्स ने हमें क्या क्या बताया. लुईस डॉट स्ट्रक्चर्स हैव टोल्ड यू, दे गिव यू sort of bonding idea कि भाई कहाँ पे डबल बॉन्ड बन सकते हैं, कहाँ सिंगल बॉन्ड बन सकता है. It shows how valence electrons are arranged. It also gives you an idea कि कोई भी कंपाउंड नोबल गैस कॉन्फ़िगरेशन के लिए क्या क्या करने को तैयार है. आयनिक बॉन्ड, कोवेलेंट बॉन्ड, कोऑर्डिनेट बॉन्ड. So it gives you an idea, but what does it not give you? It does not talk about energy. It does not talk about shape of the molecule. Okay? So the whole PPT is actually major contributions from NCERT books and some of the websites. So those question answers are from Pearson book, right? Okay. Rules for drawing the Lewis structures. There are 2 ways. I can tell you both the ways. This one is when you talk, दोनों का बेसिक आइडिया ये है कि आप बैलेंस इलेक्ट्रॉन्स को काउंट करो. अगर सपोज मैं कार्बन वैलेंस इलेक्ट्रॉन के, तो अमोनिया है और हाइड्रोजन है, तो अमोनिया के पास वैलेंस इलेक्ट्रॉन कितने हैं, 5. हाइड्रोजन के पास कितने, 3, है ना. सो आप सबके वैलेंस इलेक्ट्रॉन का टोटल सम लो. अगर एनायन है तो नंबर ऑफ चार्जेस ऐड कर दो. जैसे अगर 2 नेगेटिव का चार्ज है कार्बोनेट में तो 2 माइनस ऐड कर दो. अगर एक पॉजिटिव चार्ज है तो +1 मतलब 1 माइनस कर दो इलेक्ट्रॉन नंबर. सेंट्रल एटम वो होना चाहिए जो कि लीस्ट इलेक्ट्रोनेगेटिव हो. सो अगर मीथेन की हम बात कर रहे हैं तो कार्बन नॉर्मली हम रख दिया. अमोनिया की बात कर रहे हैं तो नाइट्रोजन है. PCl5 की बात कर रहे हैं तो P है. सो सेंट्रल आइडिया तो वही होना चाहिए ना, जैसे जब हम मॉलिक्यूल का नाम ही बना रहे हैं तो जो कम होगा वो नॉर्मली क्या होगा, सेंट्रल एटम होगा. फिर उसके बाद क्या करना है, ऑक्टेट्स कंप्लीट करने अराउंड द सराउंडिंग एटम्स. तो एक आपका सेंट्रल एटम है और उसके बाद क्या है, बॉन्डेड एटम्स है. सो बॉन्डेड एटम्स का फर्स्ट क्या कंप्लीट करें, ऑक्टेट. लेफ्ट ओवर इलेक्ट्रॉन्स मल्टीपल बॉन्डिंग के लिए और लोन पेयर के लिए यूज करें, ठीक है. और फिर भी कम पड़ जाए तो कुछ और सोचने की कोशिश करें. Okay, it doesn't matter. I'll give you another very shortcut idea, which I really like. The idea is, what do you do? This idea you've understood? You count the number of valence electrons. The next idea is, you count the number of valence electrons. This is not working. Okay. Okay. This is very basic idea actually. आप बैलेंस इलेक्ट्रॉन्स काउंट करिए, कितने इलेक्ट्रॉन्स रिक्वायर्ड है टू मेक मी हैप्पी वो काउंट करें, दोनों को सब्ट्रैक्ट करें, उसके बाद डिवाइड करें, आपको क्या मिल जाएंगे, नंबर ऑफ बॉन्ड्स. I don't know what is happening to this. Okay, I'll show you how. Let us say, I'll show you how to do it. अगर आप मेरे साथ साथ करेंगे तो you will be happy. I will also be happy. Okay. Right. The best idea. We've understood the first idea. The second idea is, if you want, you can write down. Count the number of electrons in the valence shell. This is a very, okay. Count the number of electrons in the valence shell. Count number of electrons which are required to make me happy. Happy में कब होंगी? When I achieve either octet या duplet. Right? दोनों को subtract करिए. Divide करिए by 2. और फिर उससे आपको क्या पता लग जाएगा, हाउ मेनी बॉन्ड्स आर देयर. ड्रॉ द बॉन्ड्स और फिर उसके बाद फिल द रेस्ट ऑफ द वैलेंस इलेक्ट्रॉन्स बिटवीन देम, राइट. अच्छा, अगर ये आइडिया मुझे है तो लेट अस टॉक अबाउट अमोनिया. लेट अस टॉक अबाउट अमोनिया. ये लिटरली इज अ वेरी शॉर्टकट आइडिया. इससे बहुत अच्छा लुईस डॉट स्ट्रक्चर, वो वाला पहले वाला आइडिया भी बहुत अच्छा है. वो तो बेसिक आइडिया। बेसिक आइडिया क्या है, आप वैलेंस इलेक्ट्रॉन्स गिनिए, अगर पॉजिटिव या नेगेटिव आए तो कॉरेस्पॉन्डिंगली नेगेटिव चार्ज है तो ऐड करिए, पॉजिटिव चार्ज है तो सब्ट्रैक्ट करिए, सेंट्रल एटम का केमिकल सिंबल लिखिए, उसके सराउंडिंग एटम्स को लिखिए, सराउंडिंग एटम्स का ऑक्टेट कंप्लीट करिए, उसके बाद अगर इलेक्ट्रॉन कम पड़ रहे हैं तो मल्टीपल बॉन्डिंग यूज करिए, ज्यादा पड़ रहे हैं तो नॉन बॉन्डिंग डालिए, राइट? पर ये थोड़ा सिंपल आइडिया है। कैन वी ट्राई दिस फर्स्ट? दिस विल गिव यू अ वेरी बेसिक आइडिया। ओके, नाइट्रोजन एंड हाइड्रोजन को मिला के वैलेंस इलेक्ट्रॉन्स कितने हैं बताइए? अच्छा, please understand, all these are ideas. So they fail at certain point, not necessarily being followed all the point, right? So कई बार वो 90% चल जाए तो भी हम उस आइडिया को normally use करते हैं. Okay. So how many total valence electrons will be there? नाइट्रोजन के कितने होंगे और हाइड्रोजन के कितने होंगे? कितने हाइड्रोजन है? 3. नाइट्रोजन के कितने? 5. ईच हाइड्रोजन ने 1 दिया तो 3 into 1 टोटल कितने इलेक्ट्रॉन्स हो गए? 8. How many electrons are needed to make me happy? Tell me. नाइट्रोजन से मुझे कितने चाहिए? नाइट्रोजन को कितने चाहिए to make happy? टोटल 68. टोटल कितने चाहिए? 8. हाइड्रोजन को कितने हैप्पी होने के लिए चाहिए? 2. कितने हो गए? 8 plus 14. Very good. So we have 8 electrons here and 14 electrons here. Subtract the 2. You want to find out the number of bonds. तो क्या किया आपने? 14 minus 8 divided by 2. कितना आया? 6 divided by 2 meaning 3. So आपके पास कितने bonds आए? 3. 4 एटम 3 बॉन्ड, बड़ा अच्छा काम हो गया. नाइट्रोजन, हाइड्रोजन, हाइड्रोजन, हाइड्रोजन. जैसे ही आपने 3 बॉन्ड बनाए कितने इलेक्ट्रॉन्स यूज हो गए? 6 इलेक्ट्रॉन्स. एक इलेक्ट्रॉन पेयर अभी भी बच रहा है. कौन सा वाला? नाइट्रोजन वाला. तो हो गया लोन. इजी तरीका था ना? So, okay. Let us see another example. Did everyone do it? Okay. Let's take an example of HCl. It's got hanged. इसको जरा manually change होगा. Okay. Carbon is the central atom here, right? Carbon is the central atom here. Nitrogen has कितने valence electrons? 5. How much are needed to make it happy? 8. Hydrogen has how many valence electron? 1. How many are needed to make it happy? 2. So अब हम ऐड करते हैं. पहले करते हैं ऐड किसको? वैलेंस इलेक्ट्रॉन्स को ऐड करते हैं. 5 plus 4 plus 1. कितने वैलेंस इलेक्ट्रॉन्स है? 10. नीडेड टू मेक मी हैप्पी. 8 plus 8 plus 2. हाइड्रोजन को कितने चाहिए थे हैप्पी होने के लिए? 2. कार्बन एंड नाइट्रोजन को 8. सो आई हैव टोटल नंबर ऑफ इलेक्ट्रॉन्स 18. 18 में से 10 माइनस किया डिवाइडेड बाय 2. हाउ मेनी बॉन्ड्स डू वी गेट? 4. अब 4 बॉन्ड्स है ही है तो मुझे क्या करना पड़ेगा? 4 बॉन्ड्स तो है ही है तो मैं क्या करूंगी? हाइड्रोजन और कार्बन के बीच में तो सिंगल बॉन्ड ही आ सकता है, उसका तो कुछ नहीं किया जा सकता. कार्बन और नाइट्रोजन के बीच में क्या डाल दूंगी? 3 बॉन्ड्स. बाकी मेरे पास क्या बच जाएगा? जब मैंने नाइट्रोजन ने 3 इलेक्ट्रॉन पेयर दे दिया तो उसके पास क्या बच जाएगा? लोन पेयर. इज दैट ओके? इज एवरीवन अंडरस्टूड? ओके. दिस इज नॉट वर्किंग नाउ. व्हाट? ओके. So, completing a Lewis structure. Okay. CH3Cl, everyone will be able to draw. कार्बन के पास 4 इलेक्ट्रॉन्स है. एक एक हाइड्रोजन के साथ उसने शेयर करा और एक क्लोरीन के साथ शेयर करा और उसके पास क्या आ गया? ऑक्टेट. ये तो हो जाएगा ना वही सिंपल. आई थिंक इसको मैनुअली मूव करना पड़ेगा. दिस इज नॉट मूविंग. It's not working. इसको एक बार चेक कर लेंगे, पता नहीं क्या हो गया इसे. Okay, तो next slide पहले कर दीजिए. Okay, चल रहा है. अच्छा, रिसीवर ठीक नहीं. Okay, now let's talk about HCl. HCl भी हमने बता ही लिया है. हाइड्रोजन को कितने चाहिए? 2 इलेक्ट्रॉन्स. एक बार आप ये वाला वैलिड करके देखो. HCl पे करके देखो. जो मैंने आपको शॉर्टकट बताया। हाइड्रोजन के पास कितने इलेक्ट्रॉन्स हैं? 1। क्लोरीन के पास कितने हैं? 7। टोटल कितने चाहिए? 8। कितने हो गए? 8। कितने रिक्वायर्ड है टू मेक इट हैप्पी? 10। 10 minus 8, 2, 2 by 2, 1. So कितने बीच में आएगा इलेक्ट्रॉन? 1. So इस तरह से आपको एक शॉर्टकट है, जस्ट हो सकता है कुछ जगहों पे, हर जगह तो शायद, आई डोंट नो वेदर आई हैव चेक्ड, बट मोस्टली होप दिस विल बी वैलिड. इज दैट ओके? ओके, वाटर का केस करते हैं. पेपर में ये these are things that you should know. ऑक्सीजन के पास कितने इलेक्ट्रॉन्स हैं? 6. एक एक शेयर करेगा, उसके पास क्या हो जाएगा? ऑक्टेट बन जाएगा. हाइड्रोजन ऑक्सीजन का ऑक्टेट हो जाएगा, हाइड्रोजन के क्या हो जाएंगे? डुप्ले. अमोनिया में बता चुकी हूँ, मीथेन आई हैव ऑलरेडी टॉक्ड अबाउट. मैं आपको कुछ क्वेश्चन कराऊंगी. ओके, कार्बन डाइऑक्साइड वी हैव टॉक्ड अबाउट, PCl3 वी हैव टॉक्ड अबाउट. ओके, अब आप ये बताओ, which one of the following species contains 3 bond pairs and 1 pair lone pair around the central atom? करके देखो जल्दी से. Which one of the following species contains 3 bond pairs and 1 lone pair? किसका? लोन पेयर? अरे BF3 तो हो ही नहीं सकता. क्या होगा बेटा? करके देखिए. It shouldn't take you too long. वाटर में कितने लोन पेयर्स होंगे? 2. बचेगा सा? PCl3. Please remember, BF3, AlCl3, these are remembered example. They do not have a complete octet. वाटर में कितने, हमेशा ऑक्सीजन में कितने लोन पेयर्स रह जाते हैं? 2. PCl3 नाइट्रोजन वाला केस है, तो बिल्कुल क्या होगा? 1 लोन पेयर एंड 3 बॉन्ड पेयर्स. NH2 माइनस में 2 बॉन्ड पेयर्स होते और 1 लोन पेयर रह जाता है ना? So it would be valid. Okay, so the answer is this. Okay, which of the following has maximum number of lone pairs associated with it? Shortcuts. शॉर्टकट से आ जाएगा? करके देखो, आता है कि नहीं आता? जल्दी से बताओ. हमें क्या चाहिए? मैक्सिमम नंबर ऑफ लोन पेयर्स. कौन सा? जल्दी से. हाँ, वेरी गुड. A. 8 plus 2 gives you 10. 10 and you will have how many? कितने बॉन्ड पेयर्स बने? 2 बॉन्ड पेयर्स बने. बाकी सारे क्या है? 6 क्या है? 6 इलेक्ट्रॉन बने. 3 लोन पेयर्स हैं उसके पास. सॉरी, 3 नहीं, 2 लोन पेयर्स है. क्या है? 2 लोन पेयर्स है. सॉरी, क्या है? XeF2. Okay, so you'll be able to draw the Lewis bond structures now. Lewis dot structures किसी का भी. अच्छा, NO plus देखो, जस्ट सीधी NO plus. NO plus में क्या है? नाइट्रोजन के कितने इलेक्ट्रॉन्स हैं? 5. ऑक्सीजन के कितने हैं? 6. चार्ज कितना है? +1. सो आपने प्लस, आपको इलेक्ट्रॉन में से सब्ट्रैक्ट करना है. आपने माइनस किया, आपके पास कितने बच गए? 10 इलेक्ट्रॉन्स. सबसे पहले आपने क्या बनाया? N और O को बनाया. उसके बाद आपने इनमें इलेक्ट्रॉन्स को अकोमोडेट करने की कोशिश की. तो व्हाट डू यू डू? आपने सबसे मैक्सिमम नंबर कोशिश करी, तो आपने डबल बॉन्ड बनाया. ट्रिपल बॉन्ड बना सकते हैं क्या आप? नहीं, बिकॉज ऑक्सीजन फिर अगेन एक्सीड कर जाता है अपने ऑक्टेट से. सो वी ड्रॉ अ डबल बॉन्ड. नाइट्रोजन के पास, पर वी कैन स्टिल, अभी भी उसका ऑक्टेट नहीं कंप्लीट हुआ, तो हमने क्या किया? ऑक्सीजन ने अपना इलेक्ट्रॉन कार्बन मोनोऑक्साइड की तरह शेयरिंग में लगा दिया, तो उसका एक लोन पेयर आ गया, तो ट्रिपल बॉन्ड आ गया. नाइट्रोजन पे एक लोन पेयर बच गया और पॉजिटिव. इज दैट ओके? सो दिस वन इज डन. अच्छा, अच्छा, please repeat the concept of Lewis acid. Please show the structure of carbon monoxide. Okay, both the things. First again, let us see. अभी हमने कौन सा एग्जाम्पल किया था? AlCl3 and ammonia. हमने एक BF3 का भी किया था. If we have an expand, Suppose my balance shell is not complete. In say like in the case of BF3, we are taking an example of BF3. बोरॉन में कितने वैलेंस शेल इलेक्ट्रॉन्स है 3. फ्लोरीन ने कितने कंट्रीब्यूट करे 3. सो उसके पास वैलेंस शेल में कितने इलेक्ट्रॉन्स हुए 6. इट हैज नॉट अचीव इट्स ऑक्टेट. इसने अपना क्या नहीं अचीव किया है नॉट अचीव्ड इट्स ऑक्टेट. So it can still accept what? Electrons. It can still accept electrons. What about ammonia? Ammonia में क्या हुआ? नाइट्रोजन के पास खुद के 5 थे, उसने 3 शेयर करे हाइड्रोजन के साथ, उसके पास 3 हाइड्रोजन से आगे, तो उसके पास तो कितने हो गए 8. बॉन्डिंग के बावजूद एक बार हम देख भी लेते हैं, नाइट्रोजन ने क्या किया, एक एक इलेक्ट्रॉन जो है हाइड्रोजन के साथ शेयर करा. एक एक इलेक्ट्रॉन क्या किया हाइड्रोजन के साथ शेयर करा. उसके पास होने कितने चाहिए थे 5, तो 2 ऊपर उसके पास लोन पेयर बन गए और उसका क्या हो गया ऑक्टेट कंप्लीट हो गया. अभी उसके पास ये जो नॉन बॉन्डिंग पेयर ऑफ इलेक्ट्रॉन्स है ये बचे हुए, लोन पेयर क्या है बचा हुआ है. ये इसको यूज कर सकता है, इट कैन स्टिल यूज लाइक आई एक्सप्लेन. या अमोनियम क्लोराइड जो बनता है क्या है, अमोनिया ने एक H+ के साथ कोऑर्डिनेट बॉन्ड बना लिया. क्या बना लिया कोऑर्डिनेट बॉन्ड. कोऑर्डिनेट बॉन्ड कुछ भी नहीं है, बस कोवलेंट बॉन्ड है. बस डिफरेंस क्या है, कोऑर्डिनेट बॉन्ड में एक इलेक्ट्रॉन पेयर जो है इट इज बीइंग कंट्रीब्यूटेड बाय वन ऑफ द कंबाइनिंग एटम्स. कोवलेंट बॉन्ड में क्या होता है बोथ द कंबाइनिंग एटम्स आर कंट्रीब्यूटिंग. सो व्हाट इट डज इज अमोनिया अपना लोन पेयर जो है BF3 जिसमें अभी ऑक्टेट कंप्लीट नहीं है उसको देता है. इससे क्या होता है अमोनिया अब शेयर्ड में डाला है, उसने किस में डाला है शेयरिंग में डाला है, शेयरिंग में डाला है. तो अमोनिया ने अपने इलेक्ट्रॉन पे शेयरिंग में डाला किसके साथ BF3 के साथ. तो BF3 के पास फिर भी अभी ऑक्टेट नहीं था तो उसको तो कोई फर्क नहीं पड़ा, इट अचीव्स अ ऑक्टेट. एंड अमोनिया ने क्या किया अपना शेयरिंग में डाला था, उसने छोड़ा तो है नहीं अपना. तो इस कंसेप्ट में ये क्या बन गया, इसने अपना इलेक्ट्रॉन दिया. तो दिस इज कॉल्ड एज Lewis base. This is the donor molecule. And BF3 ने क्या किया इलेक्ट्रॉन एक्सेप्ट किया. So this is called as Lewis acid and this is the acceptor. So this type of bond where एक electron pair is being donated to another molecule, just sharing, not donation actually, sharing. And by one of the combining atoms is called as coordinate bond. Next question was carbon monoxide. Okay. Show the structure of carbon monoxide. Now let's see carbon monoxide. How many electrons are there in the valence shell of carbon? 1, 2, 3, 4. What about oxygen? 6. 1, 2, 3, 4, 5, 6. Right? Oxygen will maximum want to take how many electrons? 2. Why does it want to take more? So इसको खाली कितने चाहिए? 2 to achieve the noble gas configuration. Carbon on the other hand is very, very short of the noble gas configuration. So it has to do something else. So what it does is carbon, it donates 1 electron pair to the covalent bonding. When carbon donates shares 1 electron pair with the oxygen, oxygen will also share what? 1 electron pair. This leads to oxygen achieving its octet but does not let carbon achieve its octet. क्योंकि carbon के पास अभी कितने बच गए? 2. It is 2 electron short of noble gas configuration. This has achieved its octet, right? So what does it do? Oxygen donates one of its bond pair to the coordinate bond formation. So carbon already had a double bond by sharing of 2 electrons with the oxygen. Oxygen has now contributed one of its lone pairs to the bonding. So there is another bond. Please understand coordinate and covalent bonds are same. So you have a triple bond formation. 1 oxygen lone pair is left and carbon is left with 1 lone pair. Is that okay? Understood? Okay. Which is explain that question related to Xc. Question कहाँ गया? XCF2 वाला. It's not going back. हाँ बैक कर दीजिए, बता देती हूँ. कोऑर्डिनेट बॉन्ड्स यहाँ पे. हाँ इसके बाद था ना. नहीं वो पर है कहाँ इसके बाद. XCF2 आई थिंक. नहीं इसके बाद, इन सब के बाद है. We've just done it. कहाँ किया? ये रहा, ये वाला सेकंड इसके बाद वाला. इसके बाद हाँ ये. Okay. Okay. Can we take each of the structures on their own? Okay. Who will tell me about Xc? Xenon is a noble gas. How many electrons in the valence shell? 8. So XeF2, 8 electrons in the valence. Valence shell electron pair repulsion theory तो अभी हम करेंगे वैसे, but okay. Xe में कितने इलेक्ट्रॉन्स हैं? 8 प्लस 2 किससे मिले? Xenon को फ्लोरीन से. So आपके पास 10 इलेक्ट्रॉन्स आ गए वैलेंस शेल में. किसकी? Xenon की. So Xenon के पास उसने एक इलेक्ट्रॉन अपना शेयर करा विद फ्लोरीन. फ्लोरीन का बन गया नोबल गैस कॉन्फ़िगरेशन. एक और फ्लोरीन के साथ करा, फ्लोरीन का अगेन हो गया नोबल गैस कॉन्फ़िगरेशन. अब Xenon के पास अभी कितने इलेक्ट्रॉन पेयर्स बचे हैं? 1 3 इलेक्ट्रॉन पेयर्स आर लेफ्ट. तो Xenon ने क्या किया? एक F के साथ बॉन्ड बनाया, एक दूसरे F के साथ बॉन्ड बनाया. 1 2 3 lone pairs are left. What about XeO3? XeO3 कैसे बनेगा? Xenon oxide क्या बनाएगा? It's actually forming expanded octet. It's been all the oxygens will form a double bond. So इसका भी चला गया, 2 इधर चला गया. ऑक्सीजन के पास अपने कितने बच गए? 4. इस ऑक्सीजन के पास 4. Xenon ने ये भी कंट्रीब्यूट करा. सॉरी इसको दोबारा से बनाती हूँ. XeO3 इसके कितने इलेक्ट्रॉन्स गए? 2 + 2 + 2. और कितने लोन पेयर बच गया? 1 लोन पेयर बच गया. कितना बच गया? इसके पास कितने बचे थे? 3 लोन पेयर्स. What about next? XeF4 2 लोन पेयर्स. हाँ 2 लोन पेयर. XeF4 में क्या होगा? Xenon ने क्या करा? F के साथ स्ट्रक्चर्स बनाए, 4 इलेक्ट्रॉन्स दिए. अभी इसके पास कितने बचे हैं? 4. तो 2 लोन पेयर्स. कितने बच गए? 2 लोन पेयर्स. तो इसके पास कितने हो गए? 2 लोन पेयर्स. What about XeF6? Xenon ने अगेन 1 2 सबको पता है इसका ऑक्टाहेड्रल स्ट्रक्चर है. सो X F F F F F 6 इलेक्ट्रॉन्स कंट्रीब्यूट करें. बचा कितना? 1 लोन पेयर. क्या बचा? सो इट हैज 1 लोन पेयर. सो किसके पास ज्यादा लोन पेयर्स बचे? XeF2 के पास 3 लोन पेयर्स. अंडरस्टैंड? ओके. दिस इज नॉट वर्किंग. कहाँ पे आ गया? हाँ ड्रॉबैक्स भी. फर्स्ट इससे पहले हाँ ओके. सो अब ड्रॉबैक्स ऑफ दी इससे पहले वाला. ओके. हर थ्योरी के कुछ क्या होते हैं? ड्रॉबैक्स होते हैं. कुछ ना कुछ तो ड्रॉबैक्स हरके होते हैं, मैंने आपको बताया। आज हम जिसको एक्सेप्टेड करते हैं, आज हम क्वांटम थ्योरी से रिलेटेड जितनी चीजें लेकर के आते हैं उसको करेक्ट मान सकते हैं। हो सकता है 20 years from now there will be another theories which will be highly evolved and they will say maybe quantum की ये बातें सही थी पर ये बातें कुछ wrong, right? So with time theories always change. So the first concept, so the major things that Lewis theory was not able to explain was odd number of electrons. So सबसे पहला कंसेप्ट क्या था? odd number of electrons. Expanded octet तो आपने देखा, कई जगह octet से ज्यादा इलेक्ट्रॉन्स हो रहे हैं, कई जगह octet से कम इलेक्ट्रॉन्स हो रहे हैं, जैसे बी। तो एक सिंपल सबसे पहला कंसेप्ट जो it was not able to explain was odd number of electron. For example देखो नाइट्रोजन ऑक्साइड में देखो, नाइट्रोजन हैज 5 इलेक्ट्रॉन पेयर, उसको कितना चाहिए, कितना शेयर करना है? 3 करना है शेयर। ऑक्सीजन को पर 2 ईच शेयर करना है। तो ऑक्सीजन अपना 2 शेयर करता है और नाइट्रोजन अपना क्या शेयर करता है? 3। तो कोई कॉम्बिनेशन तो बन नहीं रहा। तो नाइट्रोजन और ऑक्सीजन के केस में, NO के केस में क्या होता है? दैट नाइट्रोजन शेयर्स 2 इलेक्ट्रॉन्स विद द ऑक्सीजन, ऑक्सीजन achieves its octet but nitrogen is left with 3 electrons, 1 lone pair and 1 extra electron. In fact आप देखो, इसीलिए ये जो डबल हेडेड एरो है, दैट इज डिनोटिंग द रेजोनेंस, इट इज डिनोटिंग द रेजोनेंस। तो नाइट्रोजन और ऑक्सीजन के केस में क्या हुआ? एक बार नाइट्रोजन ने अपने पास देखा, एक स्ट्रक्चर में हमने क्या किया है कि नाइट्रोजन को अनसेटिस्फाइड रखा है और एक स्ट्रक्चर में हमने ऑक्सीजन को अनसेटिस्फाइड रखा है। एक्चुअली दोनों में से, इन तीनों में से भी कोई स्ट्रक्चर सही नहीं है, क्योंकि नेचर में तो ये चीजें अपने आप हो रही हैं, हम तो खाली उनको क्या कर रहे हैं? एक्सप्लेन करने की कोशिश कर रहे हैं। सो नाइट्रोजन NO होता है, एग्जिस्ट करता है, उसमें ऑड इलेक्ट्रॉन मॉलिक्यूल है, पर उसका स्ट्रक्चर लुईस स्ट्रक्चर से हम एक्सप्लेन नहीं कर पाते। ओके, सिमिलरली इन द केस ऑफ NO2, नाउ अगेन वी हैव ऑलरेडी सेट NO2 में क्या है बेटा? N के पास अगेन हमने कहा N3 शेयर कर सकता है, ऑक्सीजन डबल शेयर कर सकता है। सो क्या होता है? ये वाला नाइट्रोजन जो है, इस नाइट्रोजन ने 2 तो शेयर करे ऑक्सीजन के साथ, इस ऑक्सीजन का क्या कंप्लीट हो गया? ऑक्टेट। इसने एक ही शेयर करा, क्योंकि नाइट्रोजन मैक्सिमम कितने बॉन्ड्स बनाना चाहता है? 3, क्योंकि उसको 3 शेयर करने से वो काफी खुश हो जाता है। तो 3 उसने शेयर करा, पर 3 शेयर करने से ऑक्सीजन को अभी भी क्या रह गया? कमी रह गई। तो नाइट्रोजन का 1 इलेक्ट्रॉन is given to oxygen, not just given actually. You can see it's an odd electron molecule. In one case, 1 oxygen is left unsatisfied. In the other case, nitrogen is kept unsatisfied. In the third case, one of the oxygen is left unsatisfied. Right? So just see, इसमें क्या हुआ? पहले हमने एक नाइट्रोजन को अनसेटिस्फाइड रखा, फिर हमने क्या ऑक्सीजन को अनसेटिस्फाइड रखा, एक में फिर नाइट्रोजन को हमने थोड़ा सा परेशानी दी और फिर हमने ऑक्सीजन को परेशानी दी। तो कभी ना कभी किसी ना किसी को तो स्ट्रक्चर, पर ये तीनों में से कोई भी स्ट्रक्चर हमारे NO2 मॉलिक्यूल को एक्सप्लेन नहीं कर पा रहे। नेचर में NO2 एग्जिस्ट करता है, नाइट्रोजन डाइऑक्साइड एग्जिस्ट करता है कि नहीं करता, पर हम उसका स्ट्रक्चर लुईस डॉट स्ट्रक्चर से आसानी से नहीं बना पा रहे। जहां पे एक सिंगल इलेक्ट्रॉन होता है, जब हम 2 इलेक्ट्रॉन्स होते हैं तो हम लोन पेयर कहते हैं, जब एक सिंगल इलेक्ट्रॉन होता है तो हम उसे क्या कहते हैं? रैडिकल। क्या कहते हैं? अनपेयर्ड इलेक्ट्रॉन इज कॉल्ड एज अ रैडिकल। Another very different molecule is oxygen. Oxygen के लिए पेपर में most of the time you are asked very special thing about oxygen. It's a paramagnetic molecule. Why paramagnetic? It has 2 unpaired electrons. I don't know whether you've done memo, but MO theory later will explain how it done. But Lewis structure was not able to explain. इन तीनों के स्ट्रक्चर किसी ना किसी थ्योरी ने एक्सप्लेन करे, पर ल्यूइस ने नहीं करे। Lewis dot structures were not able to explain the structures of odd electron molecules. Also certain molecules like oxygen, which in nature existed and are known to be what? Oxygen is known to be a paramagnetic molecule. But according to Lewis dot structure, उसको paramagnetic नहीं होना चाहिए था। क्यों नहीं होना चाहिए था? क्योंकि उसने 2 इलेक्ट्रॉन शेयर कर लिए, तो डबल बॉन्ड बन गया, बोथ द ऑक्सीजन्स आर सैटिस्फाइड, और उसको पैरामैग्नेटिक नहीं होना चाहिए था। पर हमें क्या पता है कि इट इज अ पैरामैग्नेटिक मॉलिक्यूल। तो ल्यूइस के इस स्ट्रक्चर को, ल्यूइस ने पैरामैग्नेटिज्म को, मतलब ल्यूइस ने नहीं, ल्यूइस डॉट स्ट्रक्चर से हमने पैरामैग्नेटिज्म को एक्सप्लेन करने के लिए हमने क्या किया? हमने एक ही बॉन्ड बनाया। अगर एक बॉन्ड बनाते हैं तो ऑक्सीजन की ऑक्टेट्स कंप्लीट नहीं होते, पर एक एक इलेक्ट्रॉन बच जाएगा. इज दैट ओके? देखा आपने? ये देखो, दोबारा से देखो, इसमें थोड़ा सा डिफरेंस है. इससे Lewis dot structure, the best structure to explain O2 would have been this: two electron pairs shared, you will get an O2 molecule. But what do we get? We know that oxygen is a paramagnetic molecule. पैरामैग्नेटिक बनाने के लिए क्या हुआ? हमने खाली एक इलेक्ट्रॉन पेयर शेयर किया. एक इलेक्ट्रॉन पेयर शेयर किया तो ऑक्सीजन के ऑक्टेट्स कंप्लीट नहीं हुए, पर यस आपके पास एक एक अनपेयर्ड इलेक्ट्रॉन बोथ द ऑक्सीजन पे रह गया. दैट इज अ बायोरेडिकल हैज बीन फॉर्म. इज दैट ओके? ओके, डन. Less than 1 octet, we have already discussed this. Lewis was able to explain many things, but not how certain molecules were just satisfied by not following the octet rule. What does the octet rule? कि sharing होगी या transfer होगा just to achieve the octet. But यहाँ तो नहीं हुआ. BCl3 में क्या हुआ? बोरॉन के पास 3 इलेक्ट्रॉन्स थे, उसने क्लोरीन के साथ 3 शेयर किए, उसके पास तो 6 ही आए. But it was satisfied, isn't it? AlCl3 के पास भी यही हुआ. 3 इलेक्ट्रॉन्स थे, 3 उसने शेयर करे, फिर भी उसके पास कितने रहे? 6. ऑक्टेट अचीव नहीं हुआ, right? But again they existed in nature. Expanded octet. Certain elements are there in nature. Certain क्या? Second period से below, third period and onwards, इलेक्ट्रॉन्स में क्या होते हैं? d orbitals होते हैं. कौन से orbitals होते हैं? d orbitals. So d orbitals अगर खाली है तो उनमें इलेक्ट्रॉन्स लिए जा सकते हैं to form an expanded octet. So this concept, because at that time atomic orbitals की बात हुई ही नहीं थी. तब तक तो खाली बोहर का स्ट्रक्चर था जिसमें क्या थे? ऑर्बिट्स थे. क्या थे? ऑर्बिट्स थे. तब तो था ही नहीं ना. तो अगर था नहीं तो he could not have explained about 3D orbitals, right? So at that time he only said 8 इलेक्ट्रॉन्स होने चाहिए वैलेंस शेल में. बाद में पता लगा कि अगर आपका d ऑर्बिटल खाली है तो आप उसमें इलेक्ट्रॉन एक्सपेंड लेके एक्सपेंडेड ऑक्टेट बना सकते. जैसे ज़ेनॉन में क्या है? XeF4 में क्या है? इलेक्ट्रॉन्स बढ़ गए ना. XeF2 में भी क्या है? आपने 10 अचीव कर लिए शेयरिंग करने से. क्यों हुआ? क्योंकि कॉन्फ़िगरेशन क्या है ज़ेनॉन की, बताइए. व्हाट इज द कॉन्फ़िगरेशन ऑफ ज़ेनॉन? क्या होगी? इसके वैलेंस शेल क्या है? NS2 NP6 है. ND ऑर्बिटल्स खाली है तो वो क्या हो सकते हैं? इलेक्ट्रॉन्स एक्सेप्ट करने के लिए यूज हो सकते हैं. इज दैट ओके? क्योंकि d ऑर्बिटल्स खाली है तो वो क्या हो सकते हैं? दे कैन बी यूज्ड फॉर एक्सपैंडिंग द ऑक्टेट. इज दैट ओके? सो फिर PCl5 हो गया. PCl5 में आपने देखा फॉस्फोरस 3s2 3p3 है, 3d 0 है, d ऑर्बिटल खाली है. तो P ने क्या किया? फॉस्फोरस में कितने इलेक्ट्रॉन्स है वैलेंस शेल में? 5. उसने क्लोरीन से हाउ मेनी इलेक्ट्रॉन्स डज इट एक्सपेक्ट? 5. 5 are shared, 5 are received. How many electrons in the valence shell now? 10, more than the octet. Where are those electrons going? They're going into the d orbitals which are vacant. Is that okay? Similarly, sulfur. Atomic number 16, 2, 8 and 6. If it shares 4 electrons, it's getting how many electrons? 10 in the valence shell. Where are those 10 electrons being used? Some of those electrons are going into the 3d orbitals of the valence shell. Is that okay? For expanding the octet. There are certain other drawbacks of the octet theory. मैंने आपको बताया. हम octet theory किस concept पे based है? It's based on the concept that the noble gases do not react. But we know that there are certain compounds which are formed. XeF2, XeF4, XeF6, XeO3. Xenon compounds are there. Krypton, some compounds of krypton are there. So these compounds are there. तो noble gases भी थोड़ी बहुत तो reactivity show करती हैं. तो ये तो basic concept ही उसका हिल गया. So जिस concept पे वो so certain drawbacks were there. Also, this theory does not account for the shape. The shape was given by valence shell electron pair repulsion theory followed by VBT by MO. But this does not talk about the shape. It only talks about the bonding. It also does not talk about the relative energy of the molecules. तो मैंने आपको बताया नाइट्रोजन NO वाले स्ट्रक्चर में दो स्ट्रक्चर्स बनाए, दोनों वैलिड थे कुछ पॉइंट्स को एक्सप्लेन करने के लिए, कुछ को किसी से एक्सप्लेन करा, कुछ को किसी से एक्सप्लेन करा, पर किसकी एनर्जी लोअर है ये मुझे नहीं बताता है ल्यूइस डॉट स्ट्रक्चर. ओके, नाउ next comes is the last most important point from the Lewis dot structure point of view is formal charge. What is a formal charge? In layman terms, I have 6 valence electrons alone. मेरे साथ बॉन्डिंग हुई, मुझे कुछ इलेक्ट्रॉन्स असाइन हो गए, मेरे 4 लोगों के साथ बॉन्डिंग हुई, मुझे 4 इलेक्ट्रॉन्स असाइन हो गए. उस मेरे अपनी नेटिव स्टेट में और मेरे नेटिव स्टेट में और मेरे उस स्टेट से मेरे एक्चुअल स्टेट में थोड़ा फर्क है ना. वो फर्क जो है उसको कहते हैं हम फॉर्मल चार्ज. दैट मीन्स माय नेटिव स्टेट वाज समथिंग, I had certain valence electrons, but because of assigning some electrons due to the bonding, my state has changed. The difference between those electron numbers is called as my formal charge. Okay, so the formal charge of an atom in a polyatomic molecule is, एक बार दोबारा पहले इसको पढ़ ले definition को. What does it say? The formal charge of an atom in a polyatomic molecule or ion is defined as the difference between the number of valence electrons in an isolated or free state. मतलब मैं isolated अगर atom हूँ तो मेरे पास कुछ valence electrons है, उसका difference and the number of electrons which is assigned to that atom in the Lewis structure. मैंने Lewis structure बनाया, मेरे पास 5 इलेक्ट्रॉन्स थे अपने नेटिव स्टेट में, मुझे आपने 4 इलेक्ट्रॉन्स 8 इलेक्ट्रॉन्स असाइन कर दिए, किसमें? ल्यूइस डॉट स्ट्रक्चर में. तो वो जो डिफरेंस है जिसके कारण मुझ पे कुछ आपने चार्ज असाइन करा, वो कहलाता है मेरा फॉर्मल चार्ज. दोबारा से, it says the charge assigned to an atom in a molecule assuming that the electrons in a chemical bond are shared equally between atoms regardless of the relative electronegativity. Meaning, मैं दोबारा से रिपीट कर रहा हूँ, मैं नाइट्रोजन हूँ, मेरे पास 5 इलेक्ट्रॉन्स है. ल्यूइस डॉट स्ट्रक्चर में मेरे पास कितने इलेक्ट्रॉन्स आ गए अमोनिया के फॉर्मेशन में? 8. टोटल नंबर ऑफ इलेक्ट्रॉन्स कितने आ गए? तो मेरी नेटिव स्टेट 5 थी, मुझे 8 इलेक्ट्रॉन्स असाइन कर दिया आपने ल्यूइस डॉट स्ट्रक्चर के कारण. उसके कारण मुझ पे कुछ चार्ज आया कि नहीं आया, हो सकता नहीं आए, 0 चार्ज आ जाए, और हो सकता है मेरे ऊपर कोई पॉजिटिव या नेगेटिव चार्ज आ जाए. तो वो चार्ज जो मुझे बिकॉज ऑफ दैट डिफरेंस असाइन हुआ, दैट इज कॉल्ड एज अ फॉर्मल चार्ज. प्लीज रिमेंबर, वेरी इंपॉर्टेंट थिंग इन द फॉर्मल चार्जेस कि जो नेट चार्ज है, जो टोटल चार्ज है, जैसे अमोनिया है, अमोनियम आयन है, NH4+, the positive charge is present on a molecule as a whole. That charge is different from the formal charge. For example, ozone में, ozone is a neutral molecule. It's a neutral molecule. पर उसके हर एटम पे कुछ फॉर्मल चार्ज हो सकता है. हो सकता है, क्यों हो सकता है? क्योंकि उसके वैलेंस इलेक्ट्रॉन्स में और उसको जो इलेक्ट्रॉन्स असाइन किए थे उनमें कुछ डिफरेंस तो था ही था ना. उसके पास ऑक्सीजन में कितने वैलेंस इलेक्ट्रॉन्स होते हैं? 6. सपोज मैंने ल्यूइस डॉट स्ट्रक्चर में उसके पास इलेक्ट्रॉन्स कम कर दिए या ज्यादा कर दिए, तो कुछ उस पे चेंज आया, उसके कारण उसके ऊपर कुछ चार्ज आया. दैट चार्ज इज कॉल्ड एज द फॉर्मल चार्ज. दिस चार्ज इज डिफरेंट फ्रॉम द overall charge of the molecule. Please understand now. Okay. For example, so formal charge का formula क्या है? Total number of valence electrons minus total number of non-bonding electrons minus half the total number of bonding electrons. Okay. So formal charge on an atom in a Lewis structure क्या है? Total number of valence electrons minus total number of non-bonding electrons minus half the number of bonding electrons or shared electrons. हमें तो पता है इसके बारे में. Can we find out on each atom? Okay. Ozone. Ozone कैसा molecule है? It's a neutral molecule. Okay. So oxygen O1, O2, O3. Now let's calculate the formal charge on 1. चलिए आप, मैंने यहाँ पे किया हुआ है, पर आप भी देखिए कितने इलेक्ट्रॉन्स हैं वैलेंस शेल ऑफ ऑक्सीजन? 6. नॉन बॉन्डिंग इलेक्ट्रॉन्स इस वाले पे कितने हैं? इस स्ट्रक्चर में 2. 1 पे 2 इलेक्ट्रॉन्स, राइट? हमें इलेक्ट्रॉन्स गिनने, पेयर नहीं गिनना, ठीक है? सो 6 - 2. बॉन्डिंग इलेक्ट्रॉन पेयर्स कितने हैं उसके पास? 6 3 बॉन्ड्स बनाए ना उसने, तो कितने इलेक्ट्रॉन्स है? 6. सो 6 minus 2 मतलब नंबर ऑफ बॉन्डिंग इलेक्ट्रॉन, नॉन बॉन्डिंग, माइनस हाफ इंटू 6. तो फर्स्ट वाले एटम पे कितने का चार्ज है? +1. सेकेंड पे देखिए, which is the second atom. Number of valence electrons 6. Number of non-bonding electrons 4. Number of bonding electrons 4. Number of bonding electrons 4. So half of 4 2. So 6 minus 4 minus 2 0. तो इस वाले पे क्या रहा? Neutral. What about 3? Number of valence electrons 6. Number of non-bonding electrons 6. Number of bonding electron pair 2. Half of 2 कितना आ गया? -1. अब again I am repeating. This formal charge is a charge which is assigned to an atom in a structure. इससे हम खाली ये बता सकते, सपोज मैंने देखो, हम 5 people are sitting in a group. हम सबको ओजोन का स्ट्रक्चर बनाने को दिया जाता है, हम अपने अपने तरीके से ओजोन का स्ट्रक्चर बनाते हैं, ठीक है? मेरे ओजोन के स्ट्रक्चर ने कुछ प्रॉपर्टीज को एक्सप्लेन करा, आपके ओजोन के स्ट्रक्चर ने कुछ प्रॉपर्टीज को एक्सप्लेन करा, थर्ड वाले पर्सन के ओजोन के स्ट्रक्चर ने किसी और प्रॉपर्टीज को एक्सप्लेन करा. तीनों स्ट्रक्चर्स इंपॉर्टेंट थे मेरे लिए, मैंने तीनों स्ट्रक्चर्स को इंडिविजुअली इंपॉर्टेंस दी और मैंने तीनों को बनाया. पर मेरा मॉलिक्यूल तो किसी एक ही स्ट्रक्चर में एग्जिस्ट करता है ना, तो मैंने, हम क्या कहते हैं, यहीं से रेजोनेंस का कंसेप्ट आता है. अगर मेरे एक मॉलिक्यूल को हम 5 या 6 रेजोनेंस स्ट्रक्चर्स, 5 या 6 ल्यूइस स्ट्रक्चर्स एक्सप्लेन कर सकते हैं, तो हर पांचों स्ट्रक्चर की से कुछ प्रॉपर्टीज एक्सप्लेन होती है. Some properties are being explained by one structure, some by other, some by other. Now, it does not mean my molecule is existing in 5 different structures. It is existing in only one structure. But because I am human and I am capable of drawing structures to explain molecules, I have drawn 5 structures to explain 5 different properties. I am Malika. I have 5 different properties. You ask her, she will give me a different property. She is like this. You ask her, she gives another property. You ask her, she's giving a different characteristic about me. But all are talking about same Malika. So Malika is there alone. But 5 people are talking about her. It's like the blind elephant को 5-7 blind people ने touch किया. सबने अलग अलग तरीके से interpret करा. पर elephant तो एक ही था ना, उसकी properties तो एक ही थी. मेरी capability इतनी थी कि मैं खाली इतना interpret कर पाई. पर नेचर में मैंने नहीं बना पा रही हूँ उस मॉलिक्यूल को, तो वो प्रॉपर्टीज के कारण कई डिफरेंट स्ट्रक्चर्स हैं और हर स्ट्रक्चर इंपॉर्टेंट है मेरे लिए. कौन सा स्ट्रक्चर एक्चुअल मेरे मॉलिक्यूल को रिप्रेजेंट करता है मुझे नहीं पता, पर कुछ स्ट्रक्चर्स का कंट्रीब्यूशन ज्यादा है टू माय इंटरप्रेटिंग अ मॉलिक्यूल. तो जो स्ट्रक्चर, कौन सा स्ट्रक्चर मैक्सिमम कंट्रीब्यूशन देगा टू माय इंटरप्रिटेशन ऑफ द मॉलिक्यूल? जिसने जैसे हाथी का पैर मोटा बताया, पतली पूंछ किसी की भी हो सकती है, पर fat legs is a better interpretation. Similarly, ozone molecule can be written in different forms, but one structure which is the lowest energy structure is giving you the maximum properties of that molecule. So that is the most stable structure, right? Formal charges help you in telling you what is the energy of a structure. जिसमें ज्यादा चार्ज सेपरेशन है उसके ज्यादा एनर्जी, जिसमें कम चार्जेस है कम एनर्जी, जिसमें चार्जेस है ही नहीं उसमें न्यूट्रल, राइट? सो जो जितनी एनर्जी बढ़ती जाएगी स्टेबिलिटी कम होती जाएगी और वो स्ट्रक्चर कम मेरे मॉलिक्यूल को क्या करेगा? रिप्रेजेंट करेगा. इज दैट ओके? यू अंडरस्टूड दिस कांसेप्ट? आई विल एक्सप्लेन इन द रेजोनेंस, बट दिस इज इट. लेट्स डू इट. ओके, ये कार्बन डाइऑक्साइड का मॉलिक्यूल है. अब आप मेरे को इसमें ईच ऑक्सीजन एंड कार्बन पे मुझे फॉर्मल चार्ज निकाल के दिखाओ जल्दी से. एवरीवन please find out the formal charges on each atom, on all oxygens and on the carbon. Find out. Find out the deaths. जल्दी बताओ, हो गया? Did everyone get it? Can we check your answers? Okay, let's check your answers. Okay, first oxygen पे 0, कार्बन पे 0, थर्ड वाले ऑक्सीजन का आप मुझे बताओ 0, राइट? ओके, एक ऑल्टरनेट ल्यूइस स्ट्रक्चर लेते हैं, इस वाले में बताओ, इस वाले ल्यूइस स्ट्रक्चर में बताइए। ऑक्सीजन का कितना है? फर्स्ट वाले ऑक्सीजन का कितना है? -1, इस वाले का +1, इस वाले का -1, कार्बन का क्या है? 0। इज दैट ओके? नाउ ये तीनों ल्यूइस स्ट्रक्चर्स है, तीनों क्या है? ल्यूइस डॉट स्ट्रक्चर्स है। एक की किसकी एनर्जी सबसे कम होगी? पहले वाले की, क्योंकि इसमें सब कार्बन एंड ऑक्सीजन पे क्या था? 0 चार्ज था। इसमें कुछ चार्जेस है तो इसकी एनर्जी क्या होगी? हायर होगी। तो मोर कंट्रीब्यूटिंग स्ट्रक्चर कौन सा हुआ? नीचे पहले वाला, जिसकी एनर्जी लोअर है वो मोर कंट्रीब्यूशन कर रहा है टू द ल्यूइस डॉट रिप्रेजेंटेशन ऑफ द एक्चुअल मॉलिक्यूल। भाई एक्चुअल मॉलिक्यूल तो मुझे पता नहीं चल रहा, मैं नहीं बना पा रही हूँ, एक स्ट्रक्चर से मैं सारी प्रॉपर्टीज नहीं बता पा रही हूँ। सो आई हैव ड्रॉन थ्री स्ट्रक्चर्स। One structure which has lower energy is able to explain better properties as compared to a higher energy structure. Okay, this will lead to another concept of resonance. Okay, I'll skip this part. You will all be able to draw the Lewis dot structures now. Okay, okay. Then comes the ionic bond. Okay. We've said what are ionic compounds, what are covalent compounds. आयनिक एंड इलेक्ट्रोवैलेंट बॉन्ड का कंसेप्ट कॉजल एंड ल्यूइस ने दिया था, है ना? सो कॉजल एंड ल्यूइस ने क्या कहा? आयनिक बॉन्ड कब का इजीली बनेगा? जब फॉर्मेशन ऑफ पॉजिटिव एंड नेगेटिव आयंस इजीली होगा। आप सबने आयनाइजेशन एंथैल्पी एंड इलेक्ट्रॉन गेन एंथैल्पी पढ़ रखी है। व्हाट इज एन आयनाइजेशन एंथैल्पी? Very good. Energy required to remove an electron from an isolated gaseous atom. What is an electron gain enthalpy? Enthalpy change when a electron is added to a isolated gaseous atom to form a negative ion. Isn't right? True. Okay. तो cation easily कब बनेगा? जब ionization energy क्या होगी? कम होगी। और इलेक्ट्रॉन गेन एंथैल्पी का नेगेटिव क्या होता है? इलेक्ट्रॉन एफिनिटी, पता है ना? और इलेक्ट्रॉन एफिनिटी ज्यादा होगी तो नेगेटिव आयन ज्यादा बनेगा। तो कैटायन का आयनाइजेशन एंथैल्पी, एटम की आयनाइजेशन, मेटल की आयनाइजेशन एंथैल्पी कम, और नॉन मेटल की इलेक्ट्रॉन गेन एंथैल्पी हाई, नेगेटिव इलेक्ट्रॉन गेन एंथैल्पी, तो नेगेटिव आयन जल्दी बनेगा, है ना? सो व्हाट इज द ईज ऑफ फॉर्मेशन? द ईज ऑफ फॉर्मेशन ऑफ पॉजिटिव एंड नेगेटिव आयन डिपेंड करेगा, और किस पे डिपेंड करेगा? कि कितनी जल्दी बन रहा है। सो अगर मेरा मेटल जल्दी से इलेक्ट्रॉन लूज करके क्या बना लेता है? कैटायन, तो इजीली मेरा पॉजिटिव आयन बनेगा। जल्दी से इलेक्ट्रॉन एक्सेप्ट करके क्या बना लेता है? एनायन, तो नेगेटिव आयन इजीली बनेगा। तो इसके लिए क्या कैरेक्टरिस्टिक है? लो आयनाइजेशन एंथैल्पी एंड हाई नेगेटिव इलेक्ट्रॉन गेन एंथैल्पी। अब ionization enthalpy is always endothermic. You will always have to give electron to remove and you will always have to give energy to remove an electron from an atom, right? So it will always be an endothermic process. What about electron gain enthalpy? You could have a positive or negative value. Which is favored? High negative value is favored. But still, suppose if you have low negative value, doesn't matter. Suppose the sum of ionization energy and electron gain enthalpy is positive. Still ionic compounds बन जाते हैं कि नहीं बन जाते? Because they are favored by a certain property which is called as lattice enthalpy. What is lattice enthalpy? Lattice enthalpy is the energy required to break 1 mole of an ionic compound into its constituents ions, है ना? तो अगर मेरे पास एनर्जी, हम क्या, what do we prefer? To go from higher to lower energy. So when is lower energy? When it is an exothermic process. कब favored होते हैं reactions? जब exothermic, negative value of energies will always be favored. तो अगर मेरा even though electron affinity and ionization energy positive है, पर अगर मेरी electron lattice energy नेगेटिव है, तो वो डोमिनेट कर जाएगी over the sum और मेरा आयनिक कंपाउंड बन जाएगा, राइट? सो आपके बॉर्न हेबर्स साइकिल अब सिलेबस में इट्स नॉट देयर, बट आई विल गिव यू एन आइडिया. सॉरी, पहले इसको कर लेते हैं. ओके, सो मैंने बता दिया आयनिक बॉन्ड कैसा होता है, 9 डायरेक्शनल होता है, बोलर होता है, ये सब हम ऑलरेडी बात कर चुके हैं आयनिक कंपाउंड्स के. सो कब फेवर्ड होता है? लो आयनाइजेशन एंथैल्पी, हाई नेगेटिव वैल्यू ऑफ इलेक्ट्रॉन गेन एंथैल्पी एंड लार्ज लैटिस एनर्जी. लैटिस एनर्जी ज्यादा कब होगी? जब चार्ज छोटे होंगे और डिस्टेंस कम होगा, राइट? ओके. Okay, so lattice enthalpy we've said it is defined as the energy required to completely separate 1 mole of a solid ionic compound into the gaseous constituent ions, right? Sodium and chloride के केस में lattice enthalpy कितनी है? 788 kilojoules per mole. इतनी एनर्जी रिलीज होती है जब क्या बनता है? सोडियम क्लोराइड बनता है. जबकि उनका जो लैटिस एनर्जी एंड इलेक्ट्रॉन एफिनिटी का सम कुछ पॉजिटिव है, पर फिर भी क्योंकि ये नेगेटिव वैल्यू ज्यादा है तो ये डोमिनेट करती है और हमारा सोडियम क्लोराइड बनता है. ओके ओके, सो इसको नेक्स्ट कर दीजिए. ओके, लैटिस एंथैल्पीज जो है हम कैलकुलेट कैसे करते हैं? थर्मोकेमिकल डाटा से करते हैं कैलकुलेट. हेसेस लॉ यूज होता है. यू नो व्हाट इज इन हेसेस लॉ? When a reaction takes place in one step or multiple steps, the delta H is always the same. Enthalpy of the reaction remains the same whether the reaction will take place in one step, multiple steps. Okay, so lattice enthalpy calculate करने का वैसे कोई तरीका नहीं है. Direct calculation of lattice enthalpies can never be done. But what can we do? We can calculate by indirect method using the Hess's law. This Hess's law का usage to calculate lattice enthalpy was given by Born and Haber in the form of Born-Haber cycle, right? So Born-Haber cycle is I've already talked about. Okay, this is the Born-Haber cycle. Okay, when is a solid ion? What is a formation reaction? What is a formation reaction? You've all done thermochemistry. What is a formation reaction? Delta H formation क्या होता है? Yes. Anyone an idea? I don't want the definition. I just want simple idea, which is on which it is based. 1 mole of compound is formed from what? In their native state. Important is they are formed from their constituent elements in their native state. For example, if I talk about sodium chloride, so sodium chloride solid का formation, heat of formation reaction कौन सा होगा? Sodium solid. Sodium किस में exist करता है in the native state? Solid. Chlorine किस में exist करता है? Chlorine gas. So sodium solid plus half chlorine gas giving you sodium chloride solid, 1 mole of sodium chloride is the formation reaction, isn't it? Correct हो कि नहीं हो? बताओ. Sodium solid plus half chlorine gas giving you sodium chloride solid is this the formation reaction. This is giving you delta HF naught, heat of formation, right? Okay. So ये तो निकालना आसान हो जाता है, formation reaction. Okay. So this is M solid plus half X2 gas giving you MX solid. ये तो delta HF naught हम measure कर लेते हैं. अब क्या है? इस lattice enthalpy हमें निकालनी है. Direct तरीका है नहीं, तो हम क्या करते हैं? Indirect method. So first we take the sublimation reaction, get the value of sublimation reaction. फिर गैस बना, गैस से हमने क्या बनाया? कैटायन बनाया आयनाइजेशन एंथैल्पी के यूसेज से. डिसोसिएशन, नॉन मेटल का क्या किया? डिसोसिएशन किया, उसमें इलेक्ट्रॉन ऐड किया, दोनों ने कंबाइन करा और क्या बन गया? लैटिस एनर्जी. तो डायरेक्ट रिएक्शन का वैल्यू कितना था? डेल्टा एच एफ नॉट. बट इन सब का सम delta H sublimation plus ionization energy plus delta H dissociation plus electron gain enthalpy plus lattice energy is equal to what? Delta HF naught. हमारे पास इन सब की तो वैल्यूज पता है, तो हम किसकी वैल्यू निकाल सकते हैं? Lattice energy की. So our last numerical and I'll find up for today. Okay. Next one. Okay. So the numerical is very simple. Given the following information of magnesium oxygen and magnesium oxide, calculate the second electron gain enthalpy for the oxygen. You can also be asked to find out the value of lattice energy, whichever. Always the concept is to use the Born-Haber cycle. पहले एक reaction तो क्या होगा? Formation reaction होगा. What is the formation reaction here? Mg solid plus half O2 gas giving you MgO solid. That is delta HF naught. That value we are able to find out. Heat of formation reaction का delta HF naught निकालना तो आपको आता है ना? आप बॉन्ड एंथैल्पी से भी निकाल सकते हैं और मॉलिक्यूल्स से भी निकाल सकते हैं. पता है ना आपको? वो तो थर्मोकेमिस्ट्री में आपने किया हुआ. अब हम उस वैल्यू को यूज करेंगे. हमें किसकी वैल्यू निकालनी है? अगर सपोज लेटेस्ट एनर्जी की, तो हम क्या करेंगे? सब्लिमेशन रिएक्शन देखेंगे. अब मैग्नीशियम में 2 इलेक्ट्रॉन्स निकलने चाहिए, Mg2+ बनना चाहिए. सो फर्स्ट आयनाइजेशन एनर्जी एंड सेकेंड आयनाइजेशन एनर्जी. ऑक्सीजन का क्या होना चाहिए? डिसोसिएशन होना चाहिए. ऑक्सीजन एटम बनेगा. ऑक्सीजन को भी कितने इलेक्ट्रॉन्स गेन करने? 2 इलेक्ट्रॉन. सो E1 एंड E2. सो O- बना एंड O2+ बना. और इन Mg2+ एंड O2- के कॉम्बिनेशन से मुझे क्या मिलेगा? MgO, विच इज लेटेस्ट एनर्जी. इन सब का सम एक्सक्लूडिंग डेल्टा HF नॉट इज इक्वल टू व्हाट? डेल्टा HF नॉट. मेरे पास अगर इन सबकी वैल्यूज है या इनमें से किसी भी एक चीज की वैल्यू मिसिंग है तो मैं निकाल सकती हूँ. Isn't it? So that is the use of Born-Haber cycle. I think I will wind up now. We'll continue from here tomorrow, right? Bond parameters, covalent bonding, we'll start tomorrow. Is there any question from you? कोई है? How can we draw the Lewis structure of FeCl3 molecule? Please explain again. इनका क्वेश्चन क्या था? कौन सा वाला था? जो एच की त्रिपाठी वाला क्वेश्चन पहले क्या था? नहीं. Do you remember what was the question from HK Tripathi first? Okay, let us do first Mr. J.K. Ramtik's question. How can we draw the Lewis dot structure of FeCl3? Okay, now Lewis dot structure actually was given to explain second period and third period orbitals, right? So FeCl3 के case में valence shell में it will not be able to justify the structure because the expanded octet का concept आ जाता है FeCl3 के case में. तो FeCl3 का case is not so easy as it is looking because valence shell इस case में आपका valence shell plus inner shell दोनों ही participate करेगा in the bonding. Therefore, FeCl3 cannot be as such explained using the Lewis structure. Lewis structure of carbon dioxide by second method. एच की त्रिपाठी का पहले वाला क्वेश्चन क्या था? पता कर लेती. He's asking which has maximum number of lone pairs associated with xenon. Okay. Again that question. Which has maximum number of lone pairs associated with xenon? वो बार क्वेश्चन है. Let us solve. हमारे पास मॉलिक्यूल्स क्या थे? XCF2, XCF4, XCO3, XCF6. Okay, these are the molecules. Okay. First important point, xenon is already a noble gas. It has already completed its octet. Whatever it is doing, it is doing by expanding the octet by using the 3D orbitals. Xenon F2, XCF2. Xenon के पास 8 electrons है. 1 electron it uses to bind with the fluorine. Another electron it uses to bind with the fluorine. बन गया? So XCF2 में क्या हुआ? आपका F और आपके पास क्या है? कितने lone pairs बचे? 3 lone pairs. 1, 2, 1, 2 and 1. Is that okay? How many lone pairs are there? 3 lone pairs. Okay. What about XCF4? Again, please understand, xenon is already a noble gas. So it is doing everything by expanding the octet. Again, XCF4. 1, 2, 3, 4. So it binds with फ्लोरीन, फ्लोरीन ने अपने खत्म करे. Okay, it's become very confusing here. Doesn't matter. Fully. Okay? Okay. और जिनॉन के खुद के क्या कंप्लीट हो गए? ऑक्टेट तो ऑलरेडी कंप्लीटेड था. अब उसने 4 शेयर करे, तो 4 के साथ तो 4 शेयर करे तो उसके पास 8 ये हो गए और प्लस 4 अभी क्या है बचे हुए. सो इसके पास कितने लोन पेयर्स बचे हुए? 2 लोन पेयर्स. सो XCF4 में क्या हुआ? आफ्टर बॉन्डिंग विद 4 फ्लोरीन्स it has 2 lone pairs left. Is that okay? Xenon oxide. Okay. What about xenon oxide? वही हम xenon की तो बात ही नहीं कर रहे हैं क्योंकि xenon तो ऑलरेडी ऑक्टेट कंप्लीट कर रहा है. वो जो भी कर रहा है एडिशनल कर रहा है. अब ऑक्टेट कंप्लीट करना किसका इंपॉर्टेंट है? ऑक्सीजन का. सो ऑक्सीजन needs to complete its octet. So oxygen will complete its octet by forming double bonds. So it forms 3 double bonds. O, O, O. So कितने इलेक्ट्रॉन्स xenon ने अपने यूज कर लिए? 6 यूज कर लिए. अब इसके पास कितने लोन पेयर्स बचे? 1 लोन पेयर बच गया. 1 लोन पेयर बच गया. What about XCF6? It shares 6 electrons. 12 तो वैसे ही आ गए और 2 बच गए, मतलब 1 लोन पेयर बच गया. So XCF6 में क्या हुआ? It forms XCF6, 6 electrons it has used. It is left with 1 lone pair. It is left with 1 lone pair. So, okay. So, which is the question was which has the maximum number of lone pairs? So, which is the one which is having the XCF2 as the maximum number of lone pairs? Okay. There is another question on FeCl3. I'll repeat once again. Is a transition method. The structure is not so easily explained using the Lewis dot structure. Again, then there was carbon dioxide. अच्छा, कार्बन डाइऑक्साइड का जो हमने तीसरा स्ट्रक्चर बनाया था वो आपको याद है? कौन मुझे बताएगा? Normally, when we talk about carbon dioxide structures, please remember, normally, generally, I'm repeating these words. Generally, when we talk about carbon dioxide structure, this is the structure which is accepted. This is the structure which is accepted, right? But मैंने आपको फॉर्मल चार्ज कैलकुलेट करते समय एक और स्ट्रक्चर बताया था. कौन सा वाला स्ट्रक्चर था? जिसमें कार्बन ने क्या किया था? एक ऑक्सीजन के साथ सिंगल बॉन्ड बनाया, इस पे नेगेटिव चार्ज डाला. इसके एक के साथ उसने क्या बनाया? ट्रिपल बॉन्ड बनाया. और किसके ऊपर पॉजिटिव चार्ज डाला? किसके ऊपर डाला? राइट. ये एक अगेन ल्यूइस डॉट स्ट्रक्चर है. अगेन ये बना कैसे? सम ऑफ द प्रॉपर्टीज को एक्सप्लेन करने के लिए कार्बन के पास 4 इलेक्ट्रॉन्स थे, उसका तो ऑक्टेट वैसे ही कंप्लीट हो जाता है, तो उसने क्या किया? 3 इलेक्ट्रॉन्स एक ऑक्सीजन के साथ शेयर करे, 3 और उसके पास एक लोन पेयर बच गया. तो ये इसके पास 6 + 2 8 और इसमें कार्बन पे क्या आ गया? पॉजिटिव चार्ज. एक इलेक्ट्रॉन शेयर करा इलेक्ट्रॉन्स और इस पे क्या आ गया? नेगेटिव चार्ज. इज दैट ओके? बट दिस इज नॉट अ नॉर्मली accepted structure. Thank you, and we'll meet tomorrow and do the rest. Is that okay?
Recall that last time we studied our arithmetic progression and geometric progression. Now today we shall take up harmonic progression, and we shall also take up arithmetic or geometric progression. First, let's discuss harmonic progression. Okay. Now you please see that if you take a geometric progression, let's say that a ar ar square ar cube. Okay, let's take this geometric progression. If you take this geometric progression and assuming that all the terms are non-zero, because once, as I told you last time, that once a term becomes zero, all the subsequent terms will become zero. Okay. Now, if you take a geometric progression, assuming that all the terms are non-zero, if you take its reciprocal, what's going to happen? You will be getting 1 over ar, 1 over ar square, 1 over ar cube, so on and so forth. Is that all right? What is this sequence? It is also a geometric progression. That is, if you take the reciprocals of geometric progression, terms in the geometric progression, you will be again getting a geometric progression. But let's look at what is happening here. See, if you take a plus d, a plus 2d, a plus 3d, this is an AP. And let's assume that all the terms are non-zero. Then if you take a plus d, a plus 2d, a plus 3d, then this 1 over a plus d, 1 over a plus 2d, and 1 over a plus 3d. We're going to call this as harmonic progression. Is it all right? Because unlike geometric progression, if you take the reciprocals of arithmetic progression, it will not be arithmetic progression. We are going to call such a progression, such a sequence as harmonic progression. Okay. So can we have the first bit? Please see. This is the definition which I gave you last time. A sequence is a function whose domain is a set of natural numbers. If the range of a sequence is a subset of real numbers or complex numbers, then it is called a real sequence or a complex sequence. If you have f is from n to c, this you usually denote the sequence like this. And if you put tn is equal to fn, this is what I told you last time. I'm just repeating it. T1, T2, Tn, like that. Next. Now let's come to this. The sequence A1, A2, so on so forth, An, where Ai is not equal to 0 for each I, is said to be in harmonic progression if the sequence 1 over A1, 1 over A2, 1 over An, that forms an AP. Is that all right? That is, whenever you are given that a sequence is in harmonic progression, you just take its reciprocal, you will be reaching an arithmetic progression. Okay. Now, let's put A is equal to 1 over A1 and D is equal to 1 over A2 minus 1 over A1. Then your nth term will be defined like this. Is it all right? Nth term will be defined like this. Okay. Now, please see. Please next. See, if A and B are two non-zero numbers, then the harmonic mean of A and B is a number H, which is such that A, H, B, that forms a harmonic progression. All right. Let's look at one illustration. Now, suppose we wish to get harmonic mean between say 2 and 3. What will be the procedure? If you wish to get harmonic mean between 2 and 3, what will be your procedure? Please see what you require. You require that 2h comma 3 is an HP. Is that all right? That's an HP. Now, what does that mean? That means 1 by 2, 1 by h, 1 by 3 is an AP. So now it's very simple. What is 1 by h is equal to? 1 by h is equal to 1 by 2, 1 by 2 plus 1 by 3 Is that all right? And you simplify this, what do you get? You will be getting that this is equal to 5 by 12. Is it all right? That's equal to 5 by 12. So what do you get? You will be getting that h is equal to what? 12 by 5. So you get the value of h, that is a harmonic mean between 2 and 3. All right. In general, what's going to happen is that if you're given two numbers, A and B, two non-zero numbers A and B, such that their sum is also non-zero, then harmonic mean will be equal to 2AB over A plus B. All right. You recall the formula for arithmetic mean. What is the formula for arithmetic mean? A plus B by 2. Geometric mean? Root of AB. Please remember that while taking geometric mean, we mostly take that they are positive. Okay. Now, I'll come to this later. That harmonic mean in case of n terms. Please go to the next one. Rather, I'll say that you go to the questions. इसके बाद चलिए. Let's come to this question. Question number 1. Question number 1 is, if the first three terms of a sequence 1 by 16, A, B, 1 by 6 are in GP, and the last three terms are in harmonic progression, then what are the values of A and B? See that this is a question from your JEE main examination. I'll request you to try it. Please try. Yes, anybody nearing any answer? Which answer you're saying? A. Please think again. किसी ने आंसर सी बताया, हाँ वो भी गलत है. All right, let's look at it. See, thing is that we have to get the values of A and B from the information which we have. First is you're given that first three terms are in, these three terms are in geometric progression. If you're given that these three terms are in geometric progression, that means the square of the A, that should be equal to the product of 1 by 16 and B. Is it all right? That means you will be getting that A square is equal to 1 by 16B. Is that all right? You will be getting that A square is equal to 1 by 16B. No problem. You are also given that A, B and 1 by 6, these terms A, B, 1 by 6 are in harmonic progression, isn't it? Since you're given that these terms are in harmonic progression, what does it mean? That means B is equal to, you recall what is the formula? If you are have A, B, C, R in HP, then what is the formula? The formula is B is equal to 2AC over A plus C. Is that all right? Isn't it? Let's use it. See, you will be getting that what is B is equal to? B is equal to A plus 1 by 6 over, sorry, 2A into 1 by 6 over A plus 1 by 6. Is that all right? Okay. Now, please see, by using this and this, let's get rid of B. All right. Using this and this, let's get rid of B. You will be getting that A square is equal to 1 by 16 into 2A into 1 by 6 divided by A plus 1 by 6. Is that all right? Now, please see, you got A here, you got A square here. Can you cancel one of the A's? You will be getting A, that is equal to what? Please look at it. Can you write it like this? Please check. Is it all right? Can we write it like this? What you have to do? You have to get rid of A. First, you cancel one of the A's. Sorry, this A will not be there. Yeah, sorry, this A will be not there. Okay. Simplify this. What do you get? There is. It should be what? It should be 2. Is it? Yes, it should be 2. All right. Now, please tell me, what do you get? This is equal to 1 by 3. What do you get from here? 48A square plus how much is this equal to? 8A minus 1, that is equal to 0. 48A square plus 8A minus 1 is equal to 0. Now, you split it into linear factors. What do you get? You will be getting, please see, 48A square plus 12A minus 4A minus 1, that is equal to 0. What does this imply? This implies 12A into 4A plus 1 minus 4A plus 1, that is equal to 0, which in turn will imply that 12A minus 1 into 4A plus 1, that is equal to 0, which will imply that A is equal to 1 by 12 or A is equal to minus 1 by 4. That means after getting A is equal to 1 by 12 and A is equal to minus 1 by 4, we know that the possible answers are A and D. Isn't it? The other answers are ruled out. Okay. Now let's check up whether A is possible or not. What we have to do? We have to find out the value of B. Isn't it? We have to find out the value of B. If we wish to find out the value of B, we can find out the value of B from here. What is the value of B? 1 by 9. That does not fit into this. Isn't it? That means A is also ruled out. If you take A is equal to 1 by 12, you get B is equal to 1 by 9. That means we cannot take the answer as A. So the only option left is D. All right, let's see whether D is correct or not. Let's take A is equal to minus 1 by 4. Okay, you take A is equal to minus 1 by 4. If you take A is equal to minus 1 by 4, what is the value? What is the value of B you're going to get? 1. There we are. Is that all right? So your answer is D, that is minus 1 by 4, 1. This was the question which was asked in 2006. All right, please go to the next. All right, this should be a very simple question. I think this must be in your NCERT book. Please try. You said A. Anyone else? B. Let's take the two numbers as A and B. All right, let's take the two numbers as A and B. If you take the two numbers as A and B, then you're given that harmonic mean, the ratio of harmonic mean to geometric mean, isn't it? Ratio of harmonic mean to geometric mean. What is the harmonic mean? Harmonic mean is 2AB over A plus B. All right, and geometric mean is root of AB. You're given that H is to G, that is equal to 4:5. Is it all right? You're given that H is to G is 4:5. What does it mean? That means that 2AB over A plus B into 1 over root of AB, that is equal to 4/5. Is it all right? You get this? From here, what do you get? You will be getting that root of AB over A plus B, this is equal to 2/5. Now, please see, we do not wish to obtain the values of A and B. That is first thing which you must remember. Is it all right? We do not wish to obtain the values of A and B. What we are interested in? We are interested in the values of A is to B. Isn't it? We are interested in the value of A is to B. How do we get that? By componente dividendo? But that will be a very lengthy procedure. Can you think of something else? See, the trick is that what you do is you take the reciprocal of this. All right, you take the reciprocal of this. If you take the reciprocal, you will be getting what? You will be getting A plus B over root of AB. This is equal to 5/2. Is it all right? Now from here, can you write it like this? Root of A by B plus root of B by A. This is equal to 5/2. Check it. A by root of AB, that is equal to root of A by B. B by root of AB, that is equal to root of B by A. All right. Please see. If you look carefully, what are you getting? You're getting that you are in such a form. Isn't it? X plus 1 by X is equal to 5/2. Can you guess the values of X? 2 and 1/2. You can solve a quadratic equation. All right, you can solve a quadratic equation to obtain the value of X, or you can directly guess it. Is it all right? You will be getting X, that root of A by B, this is equal to 2 comma 1/2, which will imply what? That A by B is equal to 4 or 1/4. Your interest, now please, there could have been two answers. That is, one is 4:1, other is 1:4. Okay, but here only one option is given, that is 4:1. So we'll tick that. All right. So your answer is A, but it could be 1:4. Right? Do you need more explanation? Please, if you have any problem, you can always stop me, you can always ask it. Okay? All right, let's go to the next question. Right, you given that ABC are in harmonic progression, we wish to find out if you take the numbers A, B and A by B plus C minus A, B by C plus A minus B and C by A plus B minus C, then whether they are going to be arithmetic progression, they are going to be in arithmetic progression, geometric progression or harmonic progression. AGP, which we shall be studying later on, that is arithmetic-geometric progression. All right. So we have to check up whether what kind of numbers, what kind of sequence is this. All right. Please try. This is an AP. Huh? Maybe nahi. Please see one thing very carefully, that you should be very sure of the answer. All right. Kindly don't mind, because if you are not sure of the answer, you're going to lose 5 marks for it. All right, and that will push your rank downwards. Okay, because I don't think so. You might have discussed such a kind of problem earlier. Let's see how we can do it. See, if you're given that ABC are in harmonic progression, what conclusion immediately you can draw from it? You can immediately say that 1 over A, 1 over B, 1 over C are in arithmetic progression, isn't it? That is, first thing which we have is that 1 over A, 1 over B, 1 over C are in AP. Okay, this is the first thing which we have. Now let's focus on this. Please see, A, B plus C minus A, B, C plus A minus B, C, A plus B minus C. All right, please see, somehow from this information I have to conclude something about this, isn't it? This is what we have to do. Okay, Please see. You write this term as a plus b plus c minus 2a. Can you do that? Okay. Can you write this term as a plus b plus c minus 2b? Can you write this as c over a plus b plus c minus 2c? Do you see some kind of symmetry now, which was missing previously? Isn't it? Please see. What you do is that you look at this. Let's say that, uh, can you write the entire thing like this? K by a minus 2, 1 over k by b minus 2, 1 over k by c minus 2, where what is k is, this is equal to a plus b plus c. All right. Instead of carrying a long expression a plus b plus c, let's put it equal to k, so that we have to carry just one letter instead of three. Now please see, you concentrate on this. Somehow you have to get this from here. All right, this is an AP, isn't it? 1 over a, 1 over b, 1 over c is an AP. If you multiply each number by k, will it be still an AP? Recall that I told you this last time, isn't it? You have that k by a, k by b, k by c are in AP. Is it all right? K by a, k by b, k by c are in AP. If you subtract 2 out of each of this number, will it be still an AP? That is, you get k by a minus 2, k by b minus 2, k by c minus 2 are in AP. Do you get this? Isn't it? Can you see what is the answer? HP. Is it all right? So you will be getting that these are in harmonic progression. Okay. Let's go to the next question, please. All right. Okay, this again is a question from your JEE main examination. I don't remember the year. All right, let's see how you do it. Yes. Anybody nearing anything? Okay, let's learn some tricks. Okay, let's learn some tricks. See, first is A1, A2, A2, A3. We have no way to cancel out. Somehow, if we can cancel out the things become easier for us. All right. Okay, let's begin with the information that A1, A2, AN are in HP. Okay. Now you have A1, A2, AN are in HP. What immediate conclusion you can draw from here? 1 by A1, 1 by A2, 1 by AN are in AP. Very good. Now please see, if it is an AP, it must have a common difference, isn't it? If it is an AP, it must have a common difference. Let common difference, let D be equal to common difference of this AB. All right. What does it mean? What is D is equal to? Look at it. D is equal to 1 by A2 minus 1 by A1. That is equal to 1 by A3 minus 1 by A2. That is equal to, let's continue, 1 over AN minus 1 over AN minus 1. Is it all right? Now, please see. Look at it. Can you write it as A1 minus A2 over A1 A2? Can you write this as A2 minus A3 over A3 A2? And if you continue like that, can you write this as AN minus 1 minus AN over AN minus 1? Can you write it like that? Now let's go to the expression whose value we are seeking. All right, let's go to this expression whose value we want. You want the value of this A1 A2, A2 A3 up to AN minus 1 AN. Is that all right? Can you replace this first expression by A1 minus A2 by D? Can you replace the first expression like that? What about the second one? Can you write it as A2 minus A3 by D? Sorry, this should be plus. And if you continue like that, is it the last one equal to this? Is it okay? Can we cancel some of the terms from the numerator? What we are left with? You are left with A1 minus AN by D. Okay? You're left with this A1 minus AN by D. But nowhere in the answer we have D. We have to somehow get rid of D, isn't it? We have to get rid of D. It's not in the answer. See the other trick which we imply now. What do we do is we rewrite it like this because we know. Look at this. We see that A1, AN, etc. This is occurring in the answer, one of the answers. At least two of the answers. Can you write it as A1 AN by D into 1 over AN minus 1 over A1? Can you write it like that? Is it all right? But what is this equal to? Look at it. What is this equal to? A1 AN by D, and is it equal to this? Does D get cancelled? And what is your answer now? Is it all right? See, now once again, please see. What you have to do is, whenever you have an harmonic progression with you, always go to the reciprocals, try to bring it an arithmetic progression. That's much more easier to handle rather than harmonic progression. Okay? Okay. Uh, this must be a simple thing. Okay, let's see how you do it. One by, I don't remember the answer. It seems to be correct. How did you reach it? Seems to be okay. Anyone else? Please switch off your mobile. किसका मोबाइल बज रहा है? All right, let's look at it. See, while because you are due to appear in JEE Main, we must remember few things. First is that we must reach correct answer. Secondly, we must reach it as quickly as possible, because you have almost 30 questions which you are supposed to attempt in 1 hour. That means 2 minutes per question, almost 2 minutes, I'll say, because you have to read the question also. So for the time being you are preparing, no problem, you should try as hard as possible. But let's learn few things. First is, you're given that A, X, B are in HP. Okay, because you're given that A, X, B are in HP, can you write it as X is equal to 2AB over A plus B? All right. Okay. Now you're given that A, Y, Z, B are in GP. A, Y, Z, B are in GP. Now, if you're given that these are in GP, this is the first term, second term, third term, fourth term. Is it okay? B is equal to AR cube. That means the value of R cube is equal to B by A. That is the other thing which we have. Now, please see. You are interested in YZ. You tell me immediately what is the value of YZ? No, be careful. Okay, it is AB. See, first which you can remember is that if you are given 4 terms, then the product of middle terms is equal to product of the extremes. All right. Even if you don't wish to remember, it's very simple. See, what is Y is equal to? It is equal to AR. And what is Z is equal to? It is B by R. Isn't it? Look at it. You're given that A, Y, Z, B. These are in GP. That means Y must be R times A. Okay. And what is Z is equal to? You can obtain Z by dividing B by R. Isn't it? So you have Y is equal to AR, Z is equal to B by R. Is that all right? Let's use this once again. What is Y cube plus Z cube is equal to? Y cube plus Z, this is equal to AB. In fact, what this is equal to A cube, R cube plus B cube by R cube. Isn't it? What is R cube is equal to? B by A. So what does it become? A cube into B by A plus B cube, and this is B by A. Is it all right? What does it simplify to? This will simplify to A square B plus AB square, which is equal to AB into A plus B. Is that all right? You have the value of YZ with you. You have the value of Y cube plus Z cube with you. You have the value of X. Substitute. What do you get? Check. What do you get? If you substitute the values, what are you going to get? You have YZ over X Y cube plus Z cube. What is that equal to? This simple substitution. This is AB this is 2ab over a plus b. This is ab into a plus b. So your answer is it okay? All right, go to the next thing, please. This is slightly tricky one, but let's see, because this also is a question from your JEE main examination. All right, let me help you out. See, first is we do not know how to sum it up. No way, isn't it? That means somehow we must manipulate it in such a way that we don't have to deal with the denominator. All right. This is the first thing which you must remember. Now, see, sometimes you know what happens is that it's better to write the entire expression rather than looking at only a part of it. That is, you're looking for the timing at this expression only. But let's see, if we write the entire expression, how simplified the things will become. What is the first expression equal to? Sometimes you see that in mathematics, by rewriting the terms, the things becomes very easy. All right, let's look at the first thing, first expression. That first expression is equal to 1, 1 plus 1 by 2, 1 by 3, up to 1 by 20. Is that all right? That is the first term. What about the second term? Second term is, yes, second term is what? Second term will begin with I equal, when you put I is equal to 2, 1 by 2, 1 by 3, up to 1 by 20. Third term, all right, let's continue like that. What is the last term? It is going to be 20 into 1 by 20. And let's write the term prior to that. What is that? Is that okay? All right. Let's see how we make the things work for us. Okay, you just see one thing here. Look at this. Can you write it as 1 by 1 into 1? How many times 1 by 2 is occurring? 1 by 2 is occurring here and here. Can you write it like this? All right. 1 by 2 into 1 plus 2. You can write it like this. Do it with 1 by 3. What is that? 1 by 3 is occurring 1 plus 2 plus 3 times. Isn't it? You continue like that. And what about 1 by 20? That's occurring 1 plus 2 plus up to 20. Will you be able to handle this now? Okay, go ahead, tell me what is the answer. Yes, it should not take that much time. 105. Check your calculation, please. Check your calculation, please. 115. That should be the answer. All right, 115. See, look at it. First term, let it remain as it is. What about the second term? It becomes 3 by 2. What about the third? 1 by 3 into 3 into 4 by 2. That is the sum of first three natural numbers. All right. Next is 1 by 4 into 4 into 5 by 2. And you continue like that, 1 by 20 into 20 into 21 by 2. Is that okay? Now, see what happens. What you have to do is, this will get cancelled. This 3 will get cancelled. This will get cancelled. This will get cancelled. You are left with this 1 by 2, 2 plus 3 plus 4 plus 5 up to 21. Isn't it? What is this? Is it an AP? With first term 2, last term 21, number of terms equal to 20. How can you sum it up? You can write it as 1 by 2 into 20 by 2 into first term plus last term. And simplify this, what do you get? 5 into 23, that is 115. Okay? All right, please go to the next question. कोई question तो नहीं? कोई question? है? This is something which we have already done. Go to the next. It's a similar question we have already done. Okay, let's take a question which was asked in 2014. This was a question which was asked in 2014 B architecture entrance examination, also held by Cbse. In such questions, you see that important thing is that first of all, we must be able to write the rth term. Okay, we must be able to write r. What is rth term? Now, first is you try to write rth term. Right, try to write the general term. Yes, anybody who can write the rth term? Okay, let's observe few things. All right, let's observe few things that will help you. You please look at 48 plus 2. What is that? 50. 47 plus 3. 46 plus 4. This is first observation to write the general term. That means we know that the numerator plus the first expression in the denominator, that will add up to 50. Is it okay? Now, the second expression is not a problem. If we know the first expression, it is just the successor of the previous one. Okay, that is the second thing. Now, does it help you to write the rth term? 50 minus, let's see what she is saying. 50 minus, okay, n into n plus 1. Please always remember that you must check your term. Okay, let's check it up. If we put n is equal to 1, if we put n is equal to 1, we will be getting, we must get 48 2 into 3. But if we put n is equal to 1 here, we are not getting that. Now, will you like to modify? What it should be? 49 minus n over n plus 1 into n plus 2. All right. That means our rth term is going to be, what is TR? TR is going to be 49 minus r over r plus 1 into r plus 2. It's always a good practice to check your rth term by putting some values. Put r equal to 1. Is it okay? You're getting 48 over 2 into 3. If you put r is equal to 2, you're getting 47 over 2 plus 1, 3 into 4. No problem. That means at least we have written the general term. Now, another thing which you require in mathematics is that we must be able to split. All right, we must be able to write two separate expressions, one involving 1 over r plus 1, other involving 1 over r plus 2. How will you write that? You have to get two expressions, one involving 1 over r plus 1, other involving 1 over r plus 2. Now, I'll tell you a trick here. What you do is that you wish to write down it like in this form. I do not know what will be the numerator, that I do not know for the time being. All right, I wish to write 1 over r plus 1, 1 over here r plus 2. I do not know what are the numerator. Okay, that is after simplification I must reach this. I tell you what is the trick. What you do is you wish to write down for r plus 1. You set r plus 1 equal to 0. What is the value of r? Minus 1. What you do is in this expression you just hide r plus 1. Okay, hide r plus 1. In rest of the expression you put r is equal to minus 1. If you put r is equal to minus 1, what do you get? You will be getting, numerator will be 50, denominator will be 1. All right, you put it here, 50 by 1. Okay, now what you do as the next thing, you wish to write down what is here. You set r plus 2 equal to 0. What is r is equal to? Minus 2. Hide this expression, r plus 2. You put r is equal to minus 2 everywhere. What do you get? You will be getting 51 by minus 1. That means this is going to be minus. Okay, please check. Have we reached the correct thing? Check it. Are we getting the same expression as we had in the numerator? Sorry, as we had in the first term. Check it, check it. No problem. That means if we simplify this expression, we are going to get it. Is it all right? You have always learned one thing. It is that you know this expression, you reach this expression. But now you know how to go the other way around. All right. That is from this expression to this expression. Okay. Let's learn another trick now. See, handling these things as they are will be slightly difficult. Okay. What we do is we write it like this: 50, 1 over r plus 1 minus 1 over r plus 2 minus 1 over r plus 2. Can you write it like this? Check it. You had 51 here. I've combined one of the 50 with the previous term, left minus 1 over r plus 2. No problem. What is the advantage? When I sum it up, the terms will cancel in pairs. Is it all right? When I sum it up, this expression, the terms will cancel in pairs. I'll be left with a very simple expression. Okay. Now, all right. What we are looking for? We're looking for, this is TR. Let's remember this. This is TR. Now, you're looking for this sum. Please check. What was TR? TR was equal to 49 minus r over r plus 1 into r plus 2. Is that all right? If you put r is equal to 1, you get the first term, r is equal to 2, you get the second term, and so on and so forth. That means you're looking for r summation r equal to 1 to 48 tr. Okay? That means we are looking for, let's see what happens here. We're looking for this. Please check. Is that all right? Are you looking for this thing? Okay. What is the sum of the first expression? Write it and see what you get. You will get that all the terms except first and last will cancel out. Isn't it? Except the first and the last will get cancelled out. You will be left with what? You will be left with 50 into 1 by 2 minus, yes, that will be equal to 1 by 50. Good. All right. Are you left with this? Check it up. No problem. और ये आपके पास what is this equal to? This is, if you write it completely, 1 by 3, 1 by 4, 1 by 5 up to 1 by 50. Is it all right? The things are taking shape. Now let's see what do we get here. Okay, we are looking for what? We are looking for the value of k, isn't it? We're looking for the value of k. But although we have something similar, but we do not have 1 and 1 by 2 here, isn't it? We do not have 1 and 1 by 2 here. How can you introduce that? Look at it. You can write it 50 by 2 minus 1. Can you do that? All right. Let's minus this entire expression. Okay. Can you write it as 51 by 2 minus 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 up to 1 by 50? Please see what I have done. This minus 1 I have brought here. Okay, this minus 1 I have brought here. And you had 50 by 2 here. I have made it as 51 by 2 because this is what I require here. Isn't it? I made it as 51 by 2. That means I have added minus 1 by 2. That I have subtracted. Is it all right? I have added 1 by 2, subtracted 1 by 2. Okay. Is our expression equal to this expression? What should be the value of k? Minus 1. Is it all right? So k is minus 1. Please see. As I said, this question has already been asked in 2014. Just a year back. But the trick is you should be split the term into partial fractions. All right. That I've told you how to do it. Okay, let's go to the next question. Okay, this question number 9. This must be a simple thing. From a difficult thing to a simple thing. इसको स्विच ऑफ कर सकते हैं. They are in HP. It should be GP. Check. Video नहीं. Yes. See, you are given that ABC are in HP. As ABC are in HP, that means what is B is equal to? B is equal to what? 2AC over A plus C. All right. Now let's look at what is A minus B by 2 equal to. That is equal to A minus AC over A plus C. Is that all right? And what is this equal to? This is equal to A common, A plus C minus C over A plus C. So that is equal to A square over A plus C. All right. You have A minus B by 2 is equal to A square over A plus C. Similarly, if you look at C minus B by 2, if you look at C minus B by 2, that will turn out to be C square over A plus C. Is it all right? That will turn out to be C square over A plus C. Is it okay? Now, we wish to check up what kind of things it is. Let's check up. See, how do we do that? You got the first term as A square over A plus C. This is C, last term as C square over A plus C. The things are now A square over A plus C. Second term is B by 2. You can rewrite it as AC over A plus C. And the last term is C square over A plus C. Is it all right? You can write it like that. If you take the product of this and this, it is the square of this. Isn't it? Product of first and third term is square of the second term. That means this is must be a GP. All right, let's take the next one. Yes, this is a question from IIT. Yes? Hearing any answer? 6. Okay, you given that A1, A2, A10, these are in arithmetic progression. All right. If you given that A1, A2, A10 are in arithmetic progression, with A1 equal to how much? A1 is 2, isn't it? You got A1 is 2 and A10 that is 3. That means what is 9D is equal to? A10 minus A1 that is equal to 1, D is 1 by 9. Now what about A4? A4 is equal to A1 plus 3D. That is equal to 2 plus 1 by 3. Isn't it? That's equal to 7 by 3. All right. Now let's go to the next information. It is that H1, H10, H1, H2, H10, these are in harmonic progression. What I told you, from harmonic progression we must always go to arithmetic progression, AP. That means we have 1 over H1, 1 over H2, 1 over H10. That is are in AP. All right. And here, let's take the common difference as D, capital D. All right, let's take the common difference as capital D. All right, what is 9D is equal to? That will be equal to 1 by 3 minus 1 by 2, that is minus 1 by 6. So capital D is equal to minus 1 by 54. Is it all right? What is you're looking for? H7, isn't it? You're looking for H7. If you're looking for H7, what is that H7 is equal to? H7 is equal to what? Yes, that is equal to H1 plus 6D. Oh, sorry, capital D. What is that? Wait a moment. I have not written it correctly. It should be 1 over H7. Okay. 1 over H7 is equal to 1 over H1 plus 6D. What is that equal to? What is that? 1 over H1 is how much? 1 by 3? Sorry, 1 by 2. 1 by 2 minus 6 by 54. What is that? 1 by 2 minus 1 by 9. That is equal to 7 by 18. All right. So what is H7 is equal to? H7 is equal to 18 by 7. All right. So what is A4 into H7? That is 6. All right. Okay. A4 into H7, that is equal to 6. But you were getting not exactly 6, something less than that, isn't it? Yes. Okay, because we have to cover one more sequence today. I'll not take up a question on harmonic progression. I'll go to arithmetic and geometric progression, though there are some problems, good problems left, but I'll take up this because we are running out of time. See, so far as the arithmetic or geometric progression is concerned, what is that? So far as this is concerned, that what you have is that arithmetic or geometric progression. That is, what you do is you take, say, A1, A2, A3 are in AP. All right, and you take B1, B2, B3, these are in GP. That is, first this sequence is going in arithmetic progression, the second one is going in geometric progression. All right, now you take term wise product. That is, you think of this sequence A1 B1, A2 B2, A3 B3. you call such a sequence as an arithmetico-geometric progression. Is it all right? That is, you take term by term product, A1 by A1 into B1, A2 into B2, A3 into B3, so on and so forth. That will be called as a arithmetico-geometric progression. In fact, it will look like this: A, B, A plus D into BR, A plus 2D into BR square, A plus 3D, and like that it will continue. Is it okay? You have AB, A plus D into BR, A plus 2D into BR square, A plus 3D into BR cube, and so on and so forth. Look at it. A plus D, A plus 2D, A plus 3D. These are going in arithmetic progression. B, BR, BR square, BR cube, they are going in geometric progression. You take the term by product, you will be getting what you call as arithmetico-geometric progression. Okay. Important thing is that how do we find out the sum of such a series? See, because we are out of time, I'll just tell you what we do. What we do is that let's say that we are interested in the sum of this. If you're interested in the sum of this, write it as S is equal to AB, A plus D into BR square, sorry, BR, A plus 2D BR square, and you continue like that. Write down the last term. What is the last term? Last term is A plus n minus 1 D BR n minus 1. Is it okay? What is the term prior to that? That should be A plus n minus 2 D BR n minus 2. Is it okay? No problem with that? See, if you wish to sum up such a series, what you should do is you multiply every term by the common ratio. Okay, you multiply every term by the common ratio. If you multiply the term, every term by the common ratio, you will be getting what? You will be getting that your RS, what is that equal to? This will become AB into R. But what you do is you write AB into R just below the second term. Okay? You write AB into R just below the second term. Then next, what is the next thing? Next thing is going to be A plus D BR square, that you write below the third term. And you continue doing that. You write, you multiply this by R, you will be getting here A plus this. And you will be having one more term, it is A plus n minus 1D into BRN. Is it okay? If you multiply and shift one term, you're going to get such an expression. Now you subtract second expression from the first expression. If you subtract second expression from the first expression, what are you going to get? You will be getting that it will become 1 minus RS, left hand side. Does it become this? Okay, it becomes 1 minus R into S. What about the terms on the right hand side? This will be as it is. Next, what you're left with? DBR. Very good. You get DBR. What about the second term? Check and tell me. Next, if you subtract this out of this, you will be left with, be careful, DBR square. Isn't it? It will be DBR square. What will be the next? It will be DBR cube. And you will continue like that. If you subtract this out of this, you will be left with this A will get cancelled. You will be left with D, B, R, N minus 1 minus A plus N minus 1 D, B, R to the power of N. Is it okay? Are you left with this? Now look at this expression. Look at this expression. Does it look familiar to you? What it is? It is a GP. Can you write down its sum? You can write its sum easily. So what is its sum? Its sum is AB. What about the sum of this? Tell me, what is the answer? Yes, very good. 1 minus R to the power of N minus 1, because there are N minus 1 terms, not N. Okay, you will be getting AB dBr over 1 minus R to the power of N minus 1 over 1 minus R. All right, minus A plus N minus 1 D, Br to the power of N. Okay, this is equal to 1 minus R into S. Please see, we are assuming that R is not equal to 1. If R is equal to 1, the things will change. Okay. Now what is S is equal to? S is not a problem. S is equal to what? AB over 1 minus R plus dBr 1 minus R to the power of N minus 1 over 1 minus R whole square minus A plus N minus 1 D B to the B into R to the power of N over 1 minus R. All right. That means you can find out the sum like this. Okay. Now let me take a question. Say for instance, you wish to find out let's take a question. Let's say that we wish to find out what is this equal to 1 plus 2 by 3 plus we wish to find out the sum of this up to infinity. All right, we wish to find out the sum of this up to infinity. How do we get that? One way is we manipulate this formula. All right, one way is we manipulate this formula. That manipulation will be that you remember that if you take common ratio to be R to be between minus 1 and 1, if you take that R is between minus 1 and 1, all right, then R to the power of N will approach 0, N into R to the power of N will also approach 0. Okay, if you take this, then R to the power of N, N into R to the power of N will approach, both of them will approach 0. That means this factor will go as well as this factor will go. Is it okay? This factor will go as well as some, this factor will also go. But let's say we don't wish to do that way. The simple thing is, what is the common ratio here? What is the common ratio? 1 by 3, multiply by that. 1 by 3s, what is that equal to? You will be multiplying this by 1 by 3. Write it here. 2 by 3 square plus 3 by 3 cube plus 4 by 3 to the power of 4. You continue like that, subtract. What do you get? Yes, you will be getting here what? Subtract, you will be getting 2 by 3s, that is equal to 1 plus 1 by 3 plus 1 by 3 square plus 1 by 3 cube, so on and so forth. What is it? It's an infinite GP. What is its sum? Please, it is A over 1 minus R. That means in the present case, the sum is going to become 1 over 1 minus 1 by 3. Is that all right? What is this equal to? 3 by 2. Is that all right? What is S? Okay, no need of formula. Simply multiply by the common ratio and shift one term. Okay, you don't need to remember any formula. Can we have some questions on this? I think we have two. इसके बाद हाँ इसको yes, all right, we have already done a similar problem, but you please try this one. Because we'll run out of time. Let me tell you. See, let's look at the question. Question is, you have the question is 1 plus 2 by 3 plus 6 by 3 square. Is it all right? Plus 10 by 3 cube plus 14 by 3 to the power of 4. Is it okay? This is the question. If you look carefully, it is not AGP. Isn't it? It is not AGP. Isn't it? Because the first term is creating problem for us. All right, first term is creating problem for us. So it's not AGP. But don't worry. Let's forget the first term for the time being. Forget the first term. Is rest of it AGP? So sometimes you know what happens is that if some terms are creating problem for you, forget them for the time being. Then take them later on. I don't remember the answer. I remember the question only. I'll check up. I'll soon check up. See, please see. Even if you proceed by the same method, let's say we multiply it by the common ratio 1 by 3s. We write it here 1 by 3 plus 2 by 3 square plus 6 by 3 cube plus 10 by 3 to the power of 4. And you continue like that. Subtract. What do you get? This is 2 by 3s. Isn't it? This is 2 by 3s. What do you get on the right hand side? Right hand side is 1 plus 1 by 3 plus 4 by 3 square plus 4 by 3 cube plus 4 by 3 to the power of 4, so on and so forth. All right. Now, please concentrate only on this part. Okay. You can sum it up easily. Its sum is what? This is equal to 4 by 3 plus 4 by 3. Its sum is what? Its sum is a over 1 minus r. 4 by 9 over 1 minus 1 by 3. I'll check it up. Okay, don't worry, I'll check it up. Now, what about this equal to? This is equal to 4 by 3 plus, what do you get here? Is it 2 by 3? Please check. Please check up this term. 4 by 9 by 2 by 3. That is 2 by 3. That is equal to what? 6 by 3, that is 2. All right. 2 by 3 s is equal to 2. So s is 3. All right. Your answer was right. It is 3. All right. So this is how we find out the sum of arithmetic or geometric progression. Let's see. We have discussed two things today. One is harmonic progression. Other is how to find out the sum of arithmetic or geometric progression. Okay. Thank you so much. Okay. If you have any